The ocean is vast, but the truth is, we've only scratched its surface. Below the waves lies a domain that obeys no rules we fully understand, a realm of silence, pressure, and shadows that stretch for miles. Submarines, the only vessels made to travel this hidden world, have vanished without a trace, returned without a crew, or surfaced with logs that tell a story no one can explain. Autonomous drones sent to explore the deep never report back. Sonar pings register impossible objects moving at impossible speeds. And beneath the sediment, unmapped wreckage rusts, with no flag, no record, and no known design. This isn't science fiction. These are logged transmissions, recovered black boxes, and classified dives. Real missions, real losses, and real mysteries that no agency, military or civilian, has ever fully accounted for. So take a breath. You're about to enter a world where silence is louder than truth, and what we find in the deep may not want to be found. This is where the unexplained begins. And once we dive in, there's no turning back. Let's begin. The sea holds its breath in silence far beneath the roar of the surface. Down where the pressure flattens steel and time seems to stop, a different kind of story is written, not with ink or voice, but with absence, with a sudden vanishing, with signals that should not exist. This is the story of the ARA San Juan, a submarine built to vanish from sight, yet never meant to disappear without a trace. 44 sailors boarded it for a routine mission. None would return, and what the ocean gave back only deepened the mystery. Our journey begins not in some isolated corner of the sea, but along the windswept southern coast of South America. In Argentina, a country with a proud naval tradition, where the cold waters of the South Atlantic crash against jagged cliffs and empty beaches. It was November 2017, springtime in the Southern Hemisphere. The weather along the Patagonian coast was turning volatile, as it often does, the kind of shifting, unpredictable climate that mariners both respect and fear. The ARA San Juan, a diesel-electric submarine of the TR-1700 class, had departed the port city of Ushuaia several days earlier. It had conducted a training mission and was now making its way north toward its home base in Mar del Plata. Ushuaia is often called the southernmost city in the world, nestled against the Beagle Channel and surrounded by snow-draped peaks. It's a gateway to the Antarctic, and a place where the ocean feels especially vast, especially unforgiving. The San Juan's journey north was meant to be routine. The crew were experienced, the mission clear. They were to patrol Argentina's southern waters, monitor activity, and test systems. On board, 44 souls, men and women of discipline and courage. Some had served for decades, others were early in their careers. One was the country's first female submarine officer, a point of quiet national pride. The San Juan itself was no stranger to the deep. Originally built in Germany in the early 1980s, the vessel had served for over 3 decades, refurbished, upgraded, and deployed many times since. It wasn't cutting edge by modern naval standards, but it was seaworthy, trusted. On November 15, 2017, the crew sent their last known communication. It was brief, routine on the surface, but with an edge of urgency. They reported a short circuit in the forward battery compartment. Seawater, they said, had entered through the snorkel and caused a battery to fail. They had isolated the compartment and continued their journey on the remaining power banks. That message, time-stamped just after 7:30 a.m., would be the final transmission from the ARA San Juan. Before we continue, just a quick reminder. The visuals in this video are minimal by design. Each segment took time, carefully researched and written for a slower kind of storytelling. If you're listening while working, relaxing, or drifting off to sleep, you're in the right place. The imagery helps, but it's the story that matters. Thanks for being here. Let's return to the mystery. The submarine, along with all 44 people aboard, had vanished beneath the Atlantic. The Argentine Navy waited, then hoped, then feared. Days passed, then weeks. An international search effort began, vast and urgent, involving aircraft, sonar buoys, and dozens of ships from more than a dozen nations. The US Navy, the British Royal Navy. Specialized deep-sea equipment was flown in from Russia, Norway, and Chile. Even private companies volunteered technology. But the ocean, vast and impenetrable, gave no clues. The early focus was on a stretch of sea about 430 kilometers off the coast of Patagonia. Rough seas hampered efforts. Time ticked forward. Then, 9 days after the San Juan's disappearance, a strange discovery shifted the focus. An underwater acoustic anomaly had been detected in the area shortly after the submarine's last communication. The signal, picked up by the Comprehensive Nuclear Test Ban Treaty Organization, which maintains a global network of hydrophones designed to listen for nuclear detonations, was described as an implosion-like event. It occurred around 10:51 a.m. on November 15th, just 3 hours after the San Juan's final message. To many, it seemed like a grim confirmation. An implosion would mean a catastrophic failure, a hull breach, a sudden collapse under the immense pressure of the deep. But as the details emerged, questions began to form. Experts noted that the acoustic signature didn't fully match the kind of implosion expected from a submarine of the San Juan's size and depth. The waveform was different, too sharp, too brief, too narrow in frequency. Some compared it to the cracking of ice. Others said it resembled the detonation of a small explosive, not the drawn-out, resonant burst of a pressure-induced collapse. If it was an implosion, it was a strange one. And if it wasn't, what was it? Theories began to circulate, quietly at first, then more openly. Was there an onboard explosion? Could hydrogen buildup from the battery failure have ignited? Or had the submarine collided with something on the seafloor? Or worse, was it attacked? The official line remained cautious. A presumed implosion, likely caused by a cascading series of technical failures. But beneath the surface, doubt lingered. As weeks turned into months, families of the crew demanded answers. Some accused the Navy of hiding information. Others insisted their loved ones had reported prior issues with the vessel and that the San Juan had been pushed too far. And then, for an entire year, silence. No wreckage, no debris, no confirmed location. The ocean had swallowed the San Juan whole and refused to give it back. Until November 17th, 2018. Exactly 1 year and 2 days after its disappearance, a remote-operated submersible operated by a US company called Ocean Infinity located the wreck, 907 meters beneath the waves. Deep, cold, remote. The debris field was found along the edge of the Argentine continental shelf. In an area so difficult to search, it had previously been scanned only in low resolution. The San Juan was discovered broken into several major sections. The pressure hull had collapsed entirely, crushed as if by an invisible hand. But it was the condition of the wreck that deepened the mystery. There were no signs of fire, no scorch marks, no external damage indicating a missile or torpedo. The submarine appeared to have imploded, yes, but not in the way many expected. And not, it seemed, from the depth alone. According to investigators, the implosion occurred at a depth of approximately 600 to 900 meters, well below the submarine's maximum operating depth, but not beyond its theoretical crush depth. So, why had it failed? Some pointed again to the battery compartment. If seawater had entered the forward battery bank, it could have created a chemical reaction, generating hydrogen gas. If that gas had built up in a sealed environment, a spark could have caused an explosion. That explosion wouldn't need to be massive, just enough to compromise the pressure integrity of the hull. From there, the rest would happen in an instant. Water pressure at that depth is overwhelming. A small breach becomes a violent collapse. The hull fails catastrophically. The crew never has time to react. But even this explanation has complications. The acoustic signal captured that day doesn't reflect the frequency signature of a hydrogen explosion, nor does it line up perfectly with a hull collapse. And no one can say for certain why the backup systems failed, or why the crew didn't have time to send a distress signal. In normal conditions, an Argentine submarine in distress could release an emergency buoy, equipped with a radio transmitter. That buoy was never found, nor was there any evidence of a last-minute emergency surfacing attempt, the kind that would leave signs of ballast tank release or a forced breach. Everything had simply stopped. In the aftermath, Argentina mourned. The loss of 44 lives, sons, daughters, fathers, and mothers, was not just a national tragedy. It was an intimate wound that cut across every level of Argentine society. The crew were hailed as heroes. Ships in Buenos Aires blew their horns. Families gathered at the naval base, holding on to hope until the very end. The country declared 3 days of national mourning. But even in grief, suspicion grew. Some believed the San Juan had been pushed to sea despite known mechanical issues. Others claimed there were reports of foreign vessels operating nearby, suggesting the possibility, however remote, of a hostile encounter. And then there were those who saw patterns in the acoustic signal itself. The waveform was strange, narrow band. Some said it resembled the signature of a torpedo or even an underwater detonation of a small nuclear device. That idea was quickly dismissed by experts. No radiation was detected and no military confrontation was recorded. But still, the signal remained unusual. Its suddenness, its clarity, its precision, almost as if something had been turned off. There were even whispers, faint and unverifiable, that a US spy satellite had captured a flash near the location on the morning of November 15th. Nothing was confirmed, but the rumors, like deep currents, refused to dissipate. Later, as investigations continued and reports were published, the consensus hardened around a theory of electrical failure, gas buildup, and internal damage. It was the logical explanation. And yet, something about it never quite settled. The ocean keeps its secrets well. It doesn't need to lie. It simply erases. At 900 meters below the surface, every bolt, every panel, every human trace is flattened under tons of pressure. Wires corrode, plastics warp, steel buckles. Even truth, if you wait long enough, begins to degrade. And so the mystery of the ARA San Juan remains suspended between facts and the unknowable. We know that the crew faced a problem with their batteries, that they reported it, that they were calm, professional, composed. We know that 3 hours later, a strange sound was detected beneath the sea, something sharp, brief, and final. We know where the submarine now lies, twisted and broken on the edge of a continental slope, surrounded by silence. But what we do not know is what happened in the space between. Why didn't the emergency buoy deploy? Why didn't they send a final signal? Why does the acoustic record contradict what physics says an implosion should sound like? And why did it take a year, a full year, for the submarine to be found in a location not far from its last known position? Even with the wreck located, the data remains incomplete. Some of the submarine's components were too damaged to analyze. Others were buried under sediment or crushed into unrecognizable forms. The final report, released by an independent commission, criticized the Navy's response, noting delays, contradictions, and gaps in communication. But even the report had to concede. There was no definitive cause, only possibilities. The death of the ARA San Juan isn't just a story of mechanical failure or poor oversight. It's a story of how a vessel can vanish completely in an age of satellites, sensors, and global networks. It's a reminder that the ocean remains, in many ways, untouched, unseen, and that even with modern tools, some mysteries drift just beyond our reach. In the end, the San Juan may have simply succumbed to the sea, to 1,000 tiny factors that aligned in just the wrong way, at just the wrong moment. But maybe not. Maybe something else happened out there. Something that didn't leave evidence. Something that changed everything in an instant. We may never know. The wreckage will remain on the sea floor, undisturbed, unraised, and largely unstudied, as per the wishes of the families. It has become a grave now, a place of rest, a place of silence, but also a place of questions. Was it an accident, or did the ocean itself decide not to let go? And if that's possible, if the sea can still take what it wants, without explanation, without witness, and without return, then how many other stories lie waiting just below the waves? Stories like the ARA San Juan, crushed in darkness, echoing only in faint signals we still don't understand. Not all vanishings leave behind debris. Some leave behind a sound and a silence that stretches forever. Story 2. The Oslofjord blackout incident. Not all vanishings leave behind debris. Some leave behind a sound and a silence that stretches forever. But what about the encounters that don't end in disappearance? What about the moments when something seems to intervene, quietly, invisibly, and then vanishes just as mysteriously as it arrived? When no one goes missing, but something is still very wrong. This next mystery isn't a story of wreckage or tragedy. It's not about ghost ships, missing lifeboats, or eerie sonar recordings. Instead, it's about something subtler, quieter. A moment so precise, so surgically unexplained, that even the most hardened naval analysts were left without a framework for understanding it. It didn't happen in the Atlantic, or the deep Pacific, or in the swirling chaos of stormy waters. It happened in calm, shallow sea, in the soft fjords of Norway, in a region long mapped, long studied, and long considered safe. And it involved one of the most advanced military submarines in Northern Europe. A submarine that lost itself completely in a place where that shouldn't be possible. Let's dive into the unnerving mystery of the Oslofjord blackout incident. Norway is a land of stone and sea, a jagged coastline shaped by glaciers and time, where sheer cliffs rise out of cold blue water, and narrow inlets, known as fjords, slice deep into the interior. These fjords are quiet, reflective, often glass-like in their stillness. To sail through one is to move through a corridor of time. Villages cling to the water's edge. Pines line the rocky slopes above. And beneath the surface, the fjords stretch down, deep, narrow, and ancient. The Oslofjord is one of the best known of these passages. It's not the longest, nor the most treacherous, but it is heavily trafficked. Civilian ferries, fishing boats, and naval vessels all move through its cold channels, guided by radar and GPS, surrounded by the infrastructure of a highly modern country. Lighthouses, docks, maritime traffic controllers. There are no blind spots here, no black zones, nothing, at least officially, that should be uncharted or unstable. And yet, in the early hours of a spring morning in 2018, a Norwegian Navy submarine lost itself. Not metaphorically, not operationally, but literally. The submarine was part of a standard patrol. The kind of mission so routine, it barely registered as noteworthy. The crew was seasoned, the systems were tested, the water was calm, the weather clear. No nearby storms, no electromagnetic disturbances, no unusual military activity. And yet, all at once, every navigational system on the vessel failed. There was no warning, no gradual degradation, just silence, like someone had flipped a switch. The ship's electronic navigation suite, inertial systems, satellite positioning, compass arrays, all went dark within seconds. Internal screens flickered. Communications blinked offline. Even backup systems, which are designed to be fully independent and shielded from interference, failed in tandem. But more troubling than the blackout itself was the silence that accompanied it. No spike in electromagnetic activity, no radar interference, no jamming signature. The submarine didn't just lose its bearings, it lost its connection to the outside world. And perhaps more disturbingly, it lost its own sense of location. Submarines, unlike surface ships, rely heavily on a blend of redundant systems to maintain spatial awareness. In the absence of GPS, which can be unreliable or blocked underwater, they track motion internally. Gyroscopes, accelerometers, speed logs, all calibrated to measure the vessel's exact position over time. This internal navigation is known as dead reckoning. But in this case, even dead reckoning failed. When systems finally rebooted, approximately 12 minutes later, the vessel's location data had become incoherent. Internal logs showed no coherent drift pattern, no propulsion anomaly. And yet, when external sensors came back online and resynced with the GPS constellation, the submarine's position was off by more than 30 miles. Not in a random direction, but in a straight line shift, as if it had simply been moved 30 miles in 12 minutes, without propulsion, without maneuvering thrusters, and without any record of acceleration. For a moment, the control room went still. The officers did what trained officers do. They ran diagnostics, checked instruments, compared logs, looked for explanations, any explanation. But nothing added up. No one on the bridge had felt movement. The ocean had remained calm. There was no turbulence, no change in water pressure, no sonar anomalies, no acoustic signatures, no physical evidence of high-speed travel, forced drag, or turbulence wake. And yet, they were 30 miles from where they should have been, in silence and in stillness. The submarine, whose name has never been officially released, was a modern Ula-class vessel, part of Norway's fleet of diesel-electric submarines optimized for coastal defense and cold water operations. Known for their stealth, they are considered some of the quietest conventional submarines in the world. And while they don't match the endurance or deep diving capability of nuclear boats, their sensor suites are cutting edge. Or at least, they're supposed to be. The moment word of the anomaly reached command, the incident was flagged as a high-priority systems review. What followed was a classified investigation that, to this day, has never been fully disclosed. Officially, it was labelled a sensor malfunction. Unofficially, it remains one of the most quietly troubling incidents in modern naval history. Because here's the problem. Sensor malfunction doesn't explain it. Submarine systems are designed with multiple layers of redundancy. If one sensor fails, the others take over. If two fail, backups are engaged. If three fail, an alert is triggered. But in this case, every system went dark. Every backup failed. Every signal collapsed at the same moment. That's not a glitch. That's a coordinated event. Engineers combed through the logs, looking for signs of overload. Power surges, static discharge, software corruption. Nothing. The logs showed a clean break, like someone had deleted a chapter from the story. And when the data resumed, the submarine was somewhere else. Precisely 30 nautical miles north-northeast of its last known position. It was as if a hand had reached down through the sea, picked the vessel up, and moved it. But here's where the story gets even stranger. This wasn't the first time something like this had happened. It was just the first time it had been documented in a vessel this modern. Unconfirmed reports, many now dismissed as folklore, have circulated among submariners for decades. Stories of temporary blackouts, compass spins, sudden, inexplicable displacements, usually chalked up to localized magnetic anomalies or operator error. But in every case, there was always enough ambiguity to dismiss the report, until 2018. This time, the logs were pristine, the crew's training impeccable, the systems up to date, and still, the sea refused to cooperate. So what happened? Let's explore the theories. The first and most conservative explanation is systemic failure. That somehow a fault deep in the software stack caused a cascading collapse of the navigation suite, resulting in erroneous location data, followed by a misreporting of GPS position after reboot. It's possible, but unlikely. For the error to be consistent across all systems, including inertial sensors not connected to GPS, would require a level of simultaneous failure that borders on impossible. These systems are not built like a house of cards. They're designed for war, redundant, isolated, hardened. The second theory, more exotic, involves a localized electromagnetic anomaly. Natural EM fields can, in rare cases, cause brief disturbances in instruments. Solar flares, lightning discharges, even certain geological formations can emit low-level pulses. But again, none of that was present. The area around the Oslofjord has been mapped in immense detail. No known magnetic anomalies were recorded that day. Solar activity was minimal. There was no lightning, no auroral activity, and no radiation spikes detected by civilian monitoring stations. In short, the environment was calm. So what about military interference? Could this have been an undisclosed test of electronic warfare systems? A jamming or spoofing signal designed to blind enemy vessels? It's a theory worth considering. But even in covert exercises, navies do not typically blind their own vessels without warning, especially not in coastal waters near civilian shipping lanes. And even if such a test were run, it would require immense coordination and would likely leave some electronic signature, especially on a vessel equipped to detect it. There was none, no record, No warning, no spike. Then, there are the fringe theories, and this is where the Oslofjord incident drifts into stranger waters. Some believe the submarine passed through what's been termed a spatial anomaly, a kind of localized distortion in space-time. Not a wormhole, necessarily, but a pocket of displaced physics, where distance bends or folds. It sounds like science fiction, but proponents point to a handful of anomalous readings from unrelated maritime events. Aircraft with unexplained time loss, ships appearing briefly on radar where they shouldn't be, echoes that bounce in impossible directions. Of course, none of that is proof, but in the absence of a better explanation, the idea lingers. Another fringe theory suggests a kind of acoustic cloaking field, a speculative technology often theorized in defense circles, capable of creating not just stealth, but displacement illusions. Essentially, an external field that could mask a vessel's presence while also disorienting its sensors. In theory, it could cause a submarine to misread its environment so severely that its navigation becomes detached from reality. But no such technology is known to exist. And if it does, who was using it? And why? The Oslofjord incident is unnerving, not because it's dramatic, but because it's not. No one died. No damage was done. The submarine returned to port without further issue. On paper, it was an uneventful mission. But within those 12 minutes, something happened. Something without precedent. Something that cannot be explained by hardware failure, software corruption, environmental factors, or tactical interference. It remains officially an unsolved glitch. But to those who know the details, it's something else entirely. A moment when reality didn't behave the way it was supposed to. A moment when one of the most advanced naval platforms in the region became lost. Not for long, but long enough. Long enough to leave behind questions that, to this day, have no answers. What force can move a submarine without touching it? What phenomenon can blind every sensor on a hardened military platform? And what lies beneath the waters of the Oslofjord? That might still be watching. Perhaps the sea has folds we cannot map. Perhaps it holds doors that occasionally open and close. Or perhaps, like the whisper of wind through a forgotten corridor, there are places on Earth where the rules don't apply, where time slips, where space hums, and where even silence is a message. The Oslofjord blackout was not a tragedy. It was something stranger, a clean interruption, a silence that moved, and a mystery that, quietly, refuses to fade. Story 3. The Iris 15 drone sub disappearance. From the frigid waterways of Norway, where a modern submarine lost its senses in eerily calm waters, we now drift south to the temperate depths of the Atlantic, near the volcanic ridges of the Azores. But the mystery we're about to explore isn't about a manned vessel or a Cold War relic. It's about something newer, sleeker, designed to observe, not to act. This is the story of the Iris 15, a deep-sea drone built by France's National Centre for Scientific Research, and how, in the spring of 2021, it vanished during a routine expedition. Its final transmission was brief. 4 words: approaching structure, movement detected. A 5-second pause, and then, chillingly, not alone. Then, silence. Let's go back to the beginning. The IRIS project began as part of a quiet initiative by a coalition of French, Spanish, and Portuguese marine institutions. Their shared mission: to map tectonic anomalies along the mid-Atlantic ridge with unmatched precision, and to investigate acoustic anomalies that had been recorded intermittently since the early 2000s. The IRIS-15 was not the first of its kind. It was the culmination of a long lineage of autonomous underwater vehicles, or AUVs, designed to navigate treacherous depths without human oversight. What set IRIS-15 apart was its level of autonomy. It used an onboard AI system trained on years of deep-sea terrain data, allowing it to make independent navigational decisions in real time. Unlike traditional remotely operated vehicles, it wasn't tethered. It moved like a predator, sleek and silent, capable of operating for days at a time without surfacing. On April 12, 2021, IRIS-15 was launched from the French research vessel Pourquoi Pas, just off the western flanks of the Azores Plateau, an area of complex underwater topography known for deep rifts and towering hydrothermal vents. The drone's mission: a 3-day reconnaissance of a trench system recently revealed by satellite gravimetry. The region, unofficially labelled Sector AB-02, had shown unusual thermal gradients. Not extreme enough to suggest magma chambers, but irregular enough to raise eyebrows. The IRIS slipped into the water just after midnight, gliding into the dark like a silver eel. Its initial descent was uneventful. At 400 meters, it activated its sonar sweep. At 800 meters, it switched to magnetometer mode. By dawn, it had reached 1,200 meters and was beginning its slow pass over the trench's edge. The data it transmitted over the next 18 hours was both promising and perplexing. Minor magnetic anomalies, variations in salinity that didn't match local currents, and faint, intermittent acoustic signatures, rhythmic, almost patterned, that repeated every 11 minutes. The team on the surface assumed these were geological in origin. Microseismic events perhaps, or vent activity, but something about their symmetry was off. On April 13th, at 4:42 a.m. GMT, IRIS-15 transmitted its last full packet. It included the standard positional ping, image captures of a sheer rock face covered in unusual calcified structures, and then, tucked into the metadata, a sudden elevation in onboard AI activity. The logs showed multiple recursive loops, subroutines rechecking the same visual frames again and again, attempting to identify something. At 4:47, a new message arrived. Approaching structure, movement detected. The image attached was blurry, low light, a dark shape moving across the lower third of the frame. No scale, no context. And then a second message: not alone. Transmission cut. The command team initially assumed a hardware fault. Deep sea pressure can crush even the most robust casings if compromised. They pinged the drone repeatedly. Nothing. For the next 72 hours, the Pourquoi Pas conducted a grid search of the area using towed sonar and backup ROVs. No sign of the IRIS, no debris, no emergency beacon. It was as if it had been plucked from the ocean. What followed was a quiet but intense investigation. The official report, filed months later, cited probable catastrophic failure due to navigational collision or pressure breach. But internally, among those who had monitored the drone's descent in real time, the explanation didn't sit right. Let's pause here and look closer at what the drone was observing. The trench it entered, AB-02, had been only partially charted. Its depth ranged from 1,100 to 1,900 meters. But more striking than its depth was its layout. From above, it resembled a grid, a nearly symmetrical arrangement of parallel fissures intersecting at sharp angles. Natural? Possibly, but rare. Sonar scans had suggested the presence of vertical formations rising from the trench floor, some over 30 meters tall, spaced at regular intervals. Columns? Pillars? The drone's final photos were grainy, but they showed glimpses of structured angles, not rounded like volcanic ridges, but flat, manufactured, almost architectural. And then there was the matter of movement. What did IRIS-15 see? The automated AI is designed to ignore marine life under a certain size threshold. It filters out fish, jellyfish, and drifting invertebrates. Movement is only flagged if it exceeds those limits. Whatever passed in front of its lens was large enough to trigger a threat response. That's what the final logs revealed. A shift in AI behavior, a reallocation of power to imaging sensors, a change in heading, a delay in continuing its scan. IRIS-15 didn't just register movement, it reacted. Which raises an uncomfortable question. Can a machine sense fear? The onboard system, nicknamed Vallejo, wasn't designed to feel, but it was designed to learn. It had pattern recognition protocols based on predator-prey simulations, intended to help it avoid whales, submerged objects, or large debris fields. And in its final 5 seconds, it stalled, it paused, it ran the same calculation 3 times in a row, and it didn't move. Then, not alone, and gone. There are several theories about what happened to IRIS-15. The most conventional suggests an encounter with a submarine lava extrusion. Sudden venting could have released gas pockets, distorting sonar, triggering false movement signals, and compromising pressure integrity. But there was no seismic activity that night. Another theory points to a collision with uncharted terrain. A narrow ridge perhaps, or a drop-off. But the drone's sonar is state-of-the-art, designed to avoid such obstacles. And the absence of any physical debris casts doubt on this idea. More speculative proposals suggest entanglement, that Iris may have drifted into an abandoned fishing net or cable line. But again, no trace, no signal. Some even speculate electromagnetic interference, a pulse perhaps that disabled its circuitry and silenced its beacon. But EM pulses leave signatures. There were none. Then there are the stranger theories. Among the recovered metadata fragments, one survived. A corrupted frame of video, time-stamped milliseconds before signal loss. It shows something, a suggestion of form, not geological, not human, curved, organic. A single crescent of light reflected across a convex surface. Scale indeterminate, motion unclear. But it's there. Analysts tried to reconstruct the image, but the data was too degraded. Some claim it resembles the flank of a massive marine creature, something with plating or natural armor. Others say it could be a trick of light. But then there's the acoustic data. The IRIS-15 was recording more than visuals. It was also capturing ambient sound through a high-sensitivity hydrophone array. In the final moments, a sound can be heard. Not a groan, not a crack, but a tone. Low, rhythmic, pulsing. 6 beats, then silence. And not the kind of silence that comes from transmission failure. The kind that follows when an active sensor array is deliberately shut off. Why would an autonomous drone turn itself off? The answer might lie in its AI programming. In extreme risk situations, Vallejo is authorized to initiate a hard quiet mode, essentially powering down all active sensors to avoid attracting large predators or triggering defensive responses from military equipment. It's an emergency protocol. but it only activates when two conditions are met. 1. The presence of an object moving faster than 3 knots within a 50-meter range. 2. The detection of non-random acoustic patterns suggestive of intelligent origin. According to its own logs, both criteria were met. The last successful telemetry packet showed Valio's confidence index at 0.92, meaning the AI was over 90% certain it had encountered a moving, responsive object. The surface team never authorized a hard quiet mode, which means the drone did it on its own. That protocol has never been triggered in any previous IRIS mission. So what then was waiting in Sector AB-02? Local Azorian folklore is rich with tales of underwater cities, echoes of Atlantis, retold by fishermen and sailors for generations. They speak of ancient bells that ring beneath the waves, of stone arches glimpsed through crystal-clear currents, of lights that move without vessels. The scientific community dismisses these tales as metaphor. But in 2003, a Portuguese naval sonar sweep near the same coordinates detected what they described as anomalous vertical returns, echoes that suggested tall, thin structures unlike any natural formation. They were dismissed as technical artifacts. In 2011, a private oceanography firm deployed a mapping drone in the same region. Its report was never made public, but leaked images showed a seabed marked by right-angled depressions and at least one spiraled mound nearly 60 meters across. These events were unconnected until the IRIS-15. Its disappearance was filed under mechanical failure, but the classified addendum to the final report, leaked a year later, included one final entry. It was a handwritten note added by the mission's lead engineer, scrawled in the margin beside the last acoustic chart. 4 words, the same words the IRIS-15 sent before it vanished. Approaching structure. Movement detected. Not alone. And beneath that, in smaller handwriting, we should not return. To this day, no follow-up mission has been approved for Sector AB-02. The coordinates remain logged, the data archived, the IRIS-15 unrecovered. Some say it malfunctioned. Others believe it was taken. Not destroyed, not broken, taken. By something that noticed it first. The ocean is not empty. It watches, it waits, and sometimes it answers. The story of the IRIS-15 is not just a tale of lost technology. It's a reminder of how little we understand about the deep, not just its geography, but its silence, its stillness, and the occasional deliberate break in that silence, a shape, a pulse, a warning. Not all who vanish at sea are lost. Some are simply elsewhere, and some places, it seems, are not meant to be mapped. Not yet. Not by us. Not by machines. Not when we are not alone. Story 4. The Phantom Contact at Point Nemo. Not all sounds from the deep are ancient. Some are recent. Some cut through the silence with such precision, such timing, that they feel less like accidents of geology and more like replies. In 2010, deep in the South Pacific, a US Navy submarine logged a sonar contact unlike anything it had ever recorded. It occurred near Point Nemo, the most remote place in the ocean, farther from any landmass than any other point on Earth, a place nicknamed the Oceanic Pole of Inaccessibility, a place designed by nature and mathematics to be alone. And yet, it wasn't. What was detected that day has never been conclusively explained. It moved slowly, it moved deliberately, and it was far deeper than any known seafloor in the region. This is the mystery of the phantom contact at Point Nemo. In the late summer of 2010, the USS Anchorage, a Virginia-class fast-attack submarine, was conducting routine maneuvers in the remote southern Pacific, several hundred nautical miles north of the official coordinates of Point Nemo. Its mission, like many such patrols, was officially described as training and systems calibration. But in truth, submarines rarely drift without a reason. Even in times of peace, the ocean is a chessboard of nations. Signals are recorded, paths are monitored. The silence always is being listened to. The Anchorage had been following a quiet course, testing its new passive sonar system against the unique acoustic profile of the deep Pacific. The area near Point Nemo was chosen specifically because of its isolation. With no nearby shipping lanes, no commercial fishing, and no archipelagos for miles, it was considered a perfect acoustic sandbox. A place where ambient noise dropped low enough to isolate the most distant signals. But what they heard that week wasn't ambient. It was singular. The first contact came at 0344 hours. The sub was holding depth at just over 1,500 feet. Drifting slow, engines off, listening. At that hour, the only sounds present were the distant rumbles of current shear and the occasional croak of deep-water fauna. Then, without warning, the sonar operator flagged an anomaly. A sound. Low, but rising. Not from above, not from the side, but from beneath. It was a return. A sonar bounce, but not from their own system. It had a slope and decay profile that matched active sonar, not passive listening. Someone, or something, was pinging from the depths and returning sound. The Anchorage hadn't transmitted. Nothing in the area had. The contact was approximately 11,300 meters directly beneath them. That's over 37,000 feet, deeper than the Mariana Trench at its shallowest ridges. Deeper, in fact, than any officially mapped part of the seafloor in that region. The operator assumed it was a ghost return, a sonar hallucination caused by undersea ridges or refracted sound channels. But then the ping came again, and this time it moved, not fast, not abrupt, but with a consistency that defied coincidence. Over the next 17 minutes, the contact rose by 200 meters, then paused, then rose again. Each movement was measured, mechanical, not the drift of an object, but the path of something navigating. The Anchorage changed course slightly, enough to reposition its listening array, and narrowed the signal cone. The contact was large. At minimum estimation, it spanned over 200 meters in width. No military submarine on record, American, Russian, Chinese, even approached that mass. And still it moved. The onboard AI classified it as an acoustic unknown, a rare label but not unprecedented. The Navy's deep-sea archives have long kept track of such anomalies, things too large, too quiet, or too deep to classify. But what made this one different was the shape of the return. It wasn't jagged, it wasn't smooth, it was symmetrical. The sound bounced back not as a blur, but as a clean cross-section, as if the source was geometrically consistent. Not the rough scattering of coral shelves, not the uneven bounce of a biological swarm. Flat surfaces, even angles, parallel sides. Some on board said it looked engineered. The Navy classified the report within hours. The audio was sequestered, crew were debriefed. The Anchorage was rerouted within the week. The anomaly was not pursued, at least not officially. But the question remains, what was that object? And what was it doing ascending beneath Point Nemo? To understand the gravity of this contact, we must understand where it occurred. Point Nemo, located at 48 degrees, 52.6 minutes south, 123 degrees, 23.6 minutes west. It is the most isolated spot in the world's oceans, a point so far from land that the nearest humans are often the astronauts aboard the International Space Station, orbiting above. It lies in the heart of the South Pacific Gyre, an area of slow-moving currents, nutrient-poor waters, and biological stillness. Few fish live here. Fewer ships pass. It is a graveyard for space debris, a place where satellites and space stations are intentionally deorbited, allowed to crash into the ocean without risk to land or life. But what lies beneath? That is poorly mapped. Despite decades of oceanography, the bathymetric surveys of Point Nemo remain rough. Satellite altimetry gives a general shape, rolling seabeds, occasional ridges, but little else. Deep sonar missions in the area are rare. The ocean here is too vast, the cost too high, the interest too low, until 2010. After the Anchorage encounter, a second submarine, the USS Monitor, was dispatched 6 months later under a research pretext. This time, the mission was silent. No press, no joint task force. Just a black-budget project labeled Operation Hadros. The Monitor was equipped with advanced under-ice sonar, capable of scanning seafloor contours with extreme precision. For 2 weeks, it circled the coordinates logged by the Anchorage. And what it found was absence. Not emptiness, but anomaly. A depression in the seafloor nearly 5 miles wide, ringed by a slope that shouldn't exist. A sheer drop, sharper than known tectonics can explain, forming a perfect basin, like the imprint of something massive. And at its center, a dead zone, a sonar null, no return. The sound simply vanished. In acoustic mapping, this is highly unusual. Even the softest materials, silt, clay, reflect some return. But here, the echo just stopped. A void. The Monitor logged the site as geological hollow, indeterminate origin. It returned to base without further announcement. Since then, no publicly acknowledged naval mission has returned to Point Nemo. But whispers persist that a drone probe was sent in 2013, that it disappeared within minutes, that its tether recorded one final pressure reading, one incompatible with any known ocean depth. In recent years, conspiracy theorists have seized on the anomaly. Some believe there is an ancient base beneath Point Nemo, a structure built before humans walked the Earth. Others believe it is a portal, a place where dimensional barriers thin, where signals bounce between realities. But there is another theory, one whispered among oceanographers and former naval acousticians. It's not a base, it's not a structure, it's something alive, something massive, something dormant, not dead, but sleeping. Using the seafloor as camouflage, its surface shaped over millennia by slow tectonic shifts and sediment drift. A living mass so large and so deep that even our best instruments classify it as terrain. And what the Anchorage recorded in 2010 was not the first ping. It was the first breath, a movement, the slow stir of something that hadn't moved in a very long time. Skeptics, of course, are quick to dismiss such claims. They point out that the ocean floor is full of depressions, that acoustic shadows are common, that seafloor nulls often result from temperature layers or unusual sediment gradients. They remind us that large sonar returns can be caused by gas pockets, geological shifts, or even schools of fish arranged in vertical columns. All true, But not all anomalies are created equal. Not all occur at such depth. Not all move upward, then pause. Not all pulse. And not all happen at Point Nemo. There's a strange consistency to the 2010 signal. When later analysed by civilian researchers who gained partial access to the data through leaked FOIA requests, the signal exhibited harmonic patterns. Not just echoes, but overtones. Like the resonance of a tuning fork. Some described it as musical, structured, not random. Compared it to a bioacoustic signal, but on a scale no known creature could produce. Another likened it to a gravimetric shift, the kind that occurs when mass density changes rapidly in a compressed space. Both interpretations imply movement, intent, but there is one more detail, one that rarely appears in public summaries. The original sonar contact repeated, not immediately, not the next day, but exactly 72 hours later. A second ping, slightly higher, slightly closer, and then silence, permanent, as if the source had heard and chosen not to answer again, or worse, as if it had listened and learned. Since then, there have been no confirmed military returns to the region. The anchorage was reassigned, its crew dispersed, and its logs sealed. But among a handful of naval sonar analysts, the event remains a topic of hushed speculation. They call it the deep answer. Not a transmission, not a code, a presence, a single acknowledgement from the most remote place on Earth. Not asking for contact, but responding to it. And that brings us to the most haunting part of this story. Not the size of the contact, not the depth, not even its symmetry, but the timing. The 2010 signal occurred just months after the launch of dozens of deep-sea monitoring satellites by NOAA and its international partners. It occurred in the wake of renewed international interest in deep-sea mining, particularly in the Pacific seabed, and it occurred near the final resting place of over 200 deorbited spacecraft, all crashed in that isolated patch of sea for decades. The ocean may be vast, but it is not deaf. Perhaps, in its own way, it keeps count, and when the surface sends too many machines, too many signals, too many intrusions, something stirs. We still don't know what the anchorage found that night, or why the monitor found nothing after it. We don't know what lies beneath Point Nemo, if it's terrain, life form, or something stranger. We only know that something moved, something watched, and something replied. A slow, massive echo, a breath that didn't belong, and then silence, just as quickly as it came. Point Nemo remains the most remote location in the ocean, but remoteness does not equal emptiness. Sometimes, the farthest place on Earth is where the oldest things hide. The ocean has memory, and in places like Point Nemo, that memory might be long and very much awake. Story 5. The Ionian Sea Pulse. From the distant echo beneath Point Nemo to the breath that did not belong, a silence followed by stillness deeper than any trench could measure. We now shift east, not to the furthest point from land, but to a place hemmed in by continents, familiar coastlines, trade routes, cruise ships, and yet, beneath those sunlit waves, something stirs, something constant, a sound without a name. We turn now to the Ionian Sea, where, in the space between Italy and Greece, a hum has been detected and never fully explained. Not all ocean mysteries are hidden in the abyss. Some simply refused to stop speaking. This is the mystery of the Ionian Sea pulse. And the story begins, not in myth or ancient maps, but in modern machinery. In late spring of 2004, NATO's underwater mapping initiative, a routine operation designed to update navigational charts and scan for uncharted hazards, deployed a pair of submarines off the coast of southern Italy. These weren't the stealthy attack subs most people picture when they think of military patrols. These were survey vessels, quiet, crewed by a mix of naval engineers and civilian contractors, and fitted with arrays of sonar, bathymetric imaging gear, and magnetic field recorders. Their task was simple: chart a 500 square mile section of seabed near the Calabrian Arc. No threats, no secrets, just rock, sediment, and echoes. But something unusual happened. About 12 hours into their sweep, both submarines experienced a momentary systems freeze. The first warning came from the automated depth control system, a blinking red error code that, according to the vessel's onboard logs, shouldn't have occurred unless the submarine had surfaced. But they hadn't. They were still over 3,000 feet below the waves. Then, the magnetic compass began to spin, not in a chaotic, glitchy swirl, but in slow, methodical revolutions, as if it were tracking something. As engineers scrambled to isolate the issue, something else began to emerge. A sound, low, steady, and distant. It wasn't a ping, not a whale, not even tectonic movement. It was something almost synthetic, a tone that didn't pulse, but droned, deep, measured, and constant. Hydrophones recorded it clearly. It wasn't faint. It wasn't fading. It was simply there. No direction could be determined, and no known source matched its frequency range. The subs aborted the mission and surfaced without incident. But the data was sent up the chain. And that's when patterns began to emerge. It wasn't just that this sound had been detected. It was that it had been heard before, and not just once. Across over a dozen acoustic surveys conducted between 1997 and 2004, variations of the same low-frequency tone had appeared again and again, always in the same region, always most pronounced between depths of 2,800 and 3,400 feet. The team dubbed it the Ionian Pulse. At first, the working theory was simple. It had to be geological. The Mediterranean is geologically young, shaped by active faults, shifting subduction zones, and strange sedimentary layers that trap and redirect energy in unpredictable ways. So perhaps this sound was simply a quirk, an echo chamber effect. Seismic energy refracted and looped in some underwater acoustic pocket. But the more they looked, the less that made sense. The pulse didn't vary with earthquakes. It didn't correlate with seismic shifts. And it didn't match any known patterns of natural resonance. In fact, it was too stable. The frequency, roughly 13.96 Hz, stayed within 0.02 Hz across every recording for nearly 2 decades. That level of consistency is unheard of in natural systems. Even whales, nature's most precise vocalists, shift their calls slightly over time due to water temperature, salinity, and atmospheric pressure. But the pulse did not drift. And then came the orientation failures. In 2006, a French-operated submersible, the Minerve II, passed over the region during a deep dive engineering test. Despite calm seas, clear weather, and no external interference, its inertial navigation system suffered a 5-minute blackout. The sub did not lose power. It simply lost reference. For those 5 minutes, it was as though the ocean had erased its coordinates. The anomaly repeated in 2009, and again in 2012, always in the same 60-mile corridor between southern Italy and western Greece. Not total system failures, not electromagnetic pulses, just disorientation. As if something in the water bent not just sound, but space. NATO eventually classified the corridor as a navigational anomaly zone, a rare label typically reserved for regions with strong magnetic interference or turbulent thermal currents. But the Mediterranean has no major underwater volcanoes, no rogue magnetic fields, nothing. That should cause this. And yet, as of 2020, over 22 separate military and civilian subs have reported brief disturbances in their inertial guidance systems while passing through the area. And each time, the pulse was present, unchanged, still humming. Theories began to form, some technical, others speculative. One early idea posited that the sound was man-made, an underwater beacon perhaps, a relic of Cold War surveillance systems gone dark and abandoned. But retired naval intelligence officials who served in the region quickly dismissed that idea. First, because Cold War sonar arrays, like SOSUS, operated at different frequencies and were located in the Atlantic, not the Ionian. Second, because any man-made transmitter operating continuously for decades would require maintenance, infrastructure, and surface access, none of which existed here. Others floated the possibility of a natural resonance caused by the unique geometry of the seabed. The Ionian Trench is narrow and steep, with walls that plunge thousands of feet in sharp, angular formations. Perhaps, some theorized, it functioned like a pipe organ, amplifying ambient frequencies into a deep, singular tone. But again, that wouldn't explain the constancy. Ocean currents shift, temperatures fluctuate, and sediment moves. Natural resonance varies, but the pulse stayed the same. More fringe theories began to circulate. Some pointed to ancient infrastructure, hypothesizing that submerged ruins or unknown geological formations beneath the seabed might be vibrating due to tectonic pressure. Others speculated about methane hydrate fields releasing bubbles in rhythmic bursts. But such releases would be chaotic, irregular, and much higher in frequency. Still others wondered if the sound wasn't a resonance at all, but a broadcast. In 2014, a research team from a Mediterranean Marine Institute proposed that the pulse might be a form of echolocation, not from whales, but from something else, something deep. The team's hydrophone data revealed faint harmonics embedded within the pulse, secondary vibrations that hinted at movement. They weren't steady. They shifted subtly, rising and falling, like the sonar click patterns of dolphins, but slower, much slower, too slow to match anything known. Could it be a form of communication? One researcher noted that the pulse resembled a basal tone, a foundational signal from which other patterns could be built. It was almost musical in its simplicity, but music to whom? Then came the most unnerving development. In 2017, a Norwegian submarine operating under joint EU Research Commission guidelines passed near the anomaly zone at night. Its mission? Collect sediment samples from the southern edge of the trench. The operation went smoothly until descent. At 3,100 feet, the sub's sonar suddenly returned garbled data. The echo profile was wrong. Instead of reading a smooth seafloor, the signal reflected a shape, a vertical structure at least 30 meters tall, with smooth surfaces and what appeared to be symmetrical ridges. The shape did not remain. Moments later, the sonar cleared. The seafloor returned to normal. A fault? A glitch? Perhaps. But when analysts reviewed the audio logs, the pulse had changed. For just under 4 minutes, overlapping the sonar disturbance, the tone rose from 13.96 Hz to 14.02, then back down again, a tiny shift, almost imperceptible. Unless you were listening, the Norwegian sub returned unharmed, but the data raised questions. Was the pulse reacting to the sub's presence, or was the sub disturbing something else? In 2019, NATO quietly decommissioned further mapping in the region. No public statement was issued, but internal memos, later leaked, suggest that operational consistency was deemed unreliable due to the area's magnetoacoustic instability. That phrase, vague as it is, has no standardized definition, because no one really knows what it means. The Ionian Sea should not behave this way. It is not an abyss. It is not a trench. It is bordered by countries that have mapped it for millennia. And yet, something in its depths hums with the regularity of breath. Not tidal, not seasonal, not seismic, just there, like a presence, still, waiting. And when vessels pass overhead, when machines dip below its threshold, even briefly, that presence becomes aware. The pulse doesn't stop. It never has. But it sometimes shifts, not by much, but enough to suggest it's listening, it's tracking, or perhaps responding. Story 6. The Vanishing of Sea Drone 37. From the whispering hums of the Ionian Sea, sounds that seemed neither man-made nor natural, we now turn our gaze farther east and deeper. Thousands of miles away, near the edge of the Pacific Plate, another anomaly unfolded. But this time, there was no sonar signal, no vessel in distress, no audible cry from the deep. Just silence. Then, after 9 long days, a blip, a reappearance, and a mystery that has haunted oceanographers ever since. This is the story of Sea Drone 37, a civilian autonomous deep-sea drone that vanished near one of the most remote trenches on Earth, only to re-emerge in a place no one could explain. Let's dive into the mystery of the vanishing drone and what it might suggest about the uncharted void that surrounds the Kermadec Trench. The Pacific Ocean is vast, but some corners of it feel even farther removed from the known world than others. Roughly 600 miles northeast of New Zealand lies a submerged scar in the Earth's crust, known as the Kermadec Trench. It's not as famous as the Mariana. It doesn't claim the title of deepest point on Earth, but in many ways it's stranger, less studied, more remote, and far less forgiving. The Kermadec is part of a complex subduction zone, a place where the Pacific Plate is slowly diving beneath the Indo-Australian Plate. This violent meeting of tectonic giants gives rise to immense underwater pressure, deep fissures, and a silence so complete it seems unnatural. It was here in May of 2019 that Sea Drone 37 began its mission. Unlike military submersibles or government-operated bathyscarfs, Sea Drone 37 was a civilian prototype, part of an academic partnership between a university in Wellington and a consortium of ocean research institutions across the Pacific Rim. The drone itself was roughly the size of a small kayak, sleek, dark, designed to dive to depths of 9,000 meters. Its purpose was simple: map the trench, catalogue biodiversity. Listen, but the ocean had other plans. Sea Drone 37 deployed from the deck of the research vessel Himera Horizon just after sunrise on May 14th. The launch was smooth, its descent uneventful. At 0932 hours, the drone reached a depth of 6,780 meters, near a narrow slope that dropped steeply toward the Hadal zone. It transmitted standard telemetry: temperature, salinity, pressure. No anomalies, no disruptions. Then, at 0934, it blinked out. No warning, no mechanical preamble. One moment, it was there. The next, gone. The team aboard the Himera Horizon scrambled to re-establish contact. They ran diagnostics on the satellite link. They checked signal repeaters. They waited for the drone to resurface. But Sea Drone 37 did not come back. What followed was a quiet kind of panic, the kind only scientists know. Not of fear for life or limb, but for data, for time, for answers. For 9 days, the ocean held its breath. No signal, no drift trajectory, not even a faint ping from its backup transponder. The ship circled the drop site for 72 hours before eventually abandoning the search. The drone, they assumed, was lost, either crushed by pressure, buried in sediment, or swallowed by a sudden landslide deep within the trench. But on the 10th morning, 2,300 miles away, off the coast of Tonga, a satellite receiver at a NOAA station picked up a brief handshake. It lasted less than 90 seconds, a tiny burst of data, a GPS ping, and then silence again. The coordinates placed the drone floating in open ocean, just below the surface, far outside its operational range. No vessel had reported recovering it. No beacon had been triggered. No ocean current could account for the distance covered in the time elapsed. When a reconnaissance vessel finally reached the coordinates 3 days later, the sea was empty. Sea Drone 37 was gone again. Whatever had surfaced for those 90 seconds had already vanished. And what made it stranger still was the data it transmitted. Compressed, partial, and fragmented, but real. Within that tiny handshake was a single video frame, a still image, time-stamped from 6 days earlier, 3 days after the drone had vanished. The image showed the ocean floor, faintly illuminated by Sea Drone 37's onboard lights. But this was no ordinary terrain. The seabed appeared uneven, rippled, almost like draped fabric. Small, angular protrusions jutted from the sediment, too regular to be rocks. The edges were sharp, and just at the edge of frame, a shape. Not a creature, not a structure, something else. A curve, a reflection, a surface too smooth. Then the frame cut out. The rest of the file was corrupted beyond repair. For weeks, analysts tried to piece together what had happened. But the more they studied the image, the more questions it raised. What had the drone recorded? Why had it waited 3 days to surface? And how had it traveled over 2,000 miles without propulsion, across shifting currents and volatile thermal zones? To understand the strangeness of that journey, we need to talk about the South Pacific Gyre. It's a massive ocean current, a slow, swirling system that spans thousands of miles, moving clockwise across the basin. It is not, however, a straight shot from New Zealand to Tonga. The path is indirect, winding, turbulent, and Sea Drone 37 wasn't a buoy. It was a submersible designed to dive, not drift. Without power, it wouldn't float steadily, and without propulsion, it couldn't steer. To reach its final transmission point in 9 days, it would have needed to travel faster than any deep drifting object ever recorded in that region. Some researchers suggested that perhaps it had hitched a ride, caught in an upwelling thermal plume, or trapped in a vortex eddy and launched like a slingshot across the ocean. But even then, it didn't explain the delay. Why had it resurfaced after 3 days of radio silence? And how did it survive the pressure if it had lost power? Here's where the mystery deepens. Because buried in the drone's partial data log was another anomaly, a string of sensor readings from just before the blackout. At 09:33:21, less than a minute before going silent, Sea Drone 37 recorded a sharp, localized drop in ambient noise. Normally, the deep ocean is filled with subtle sounds. The groan of tectonic plates, distant whale calls, the fizz of descending debris. But in that moment, all of it stopped. The hydrophones registered a flat line, as if something had muffled the sea itself. Then, at 09:33:24, just 3 seconds later, the drone's magnetometer spiked. It wasn't seismic, it wasn't electrical, it was directional. A vector shift so abrupt, the onboard stabilization protocol kicked in. Sea Drone 37 began to yaw, as if pivoting towards something unseen. And then, the data ends. There was no catastrophic pressure spike, no flooding alert, no structural breach, just a complete and instantaneous loss of signal. It was as if the drone had been taken, not destroyed, not dismantled, just moved. And whatever moved it far. In the months that followed, theories poured in. Some blamed hardware failure. Others posited a sudden implosion, a silent crushing under unexpected stress. But pressure logs showed no spike, no deformation, no warning. A catastrophic implosion at that depth would have generated a detectable acoustic signature. Nearby monitoring buoys would have heard it. They heard nothing. Then came the speculations that the drone had been caught in a previously unmapped fissure, some vertical chute carved by tectonic shifts leading to an unknown chamber, that it had fallen into a zone of zero acoustic return, an anechoic cul-de-sac in the seabed. Some even whispered that the drone had encountered a current of unnatural origin, a kind of deep-sea jet stream, guided not by surface winds, but by something far older. One fringe theory suggested a magnetic anomaly, not from Earth, but from within Earth. A reverse polarity field, narrow, localized, and buried in the trench's sidewall. Such a field, if strong enough, could disrupt sensors, interfere with propulsion, and perhaps even redirect a lightweight submersible. But magnetic mapping of the region showed no such field. Then again, it had never been mapped at 6,780 meters. Another theory, more unsettling, drew comparisons to so-called lost time phenomena. Instances where mechanical systems experience unexplained pauses in data recording, only to resume with no loss of power and no memory of the interruption. Some pointed to gravitational anomalies, others to psychological projection, that the single frame of seabed was nothing more than corrupted light scatter, misinterpreted by wishful minds. But there was one piece of evidence that none could explain. A fragment, recovered from the seafloor near the drone's original descent point, not by the Kawaka horizon, but by a Japanese research vessel passing through the region 6 months later. It was a piece of carbon fiber hull, no longer than a human hand, partially fused, partially shattered, with micro abrasions that suggested immense pressure and sudden release. Tests confirmed it came from Sea Drone 37, but the damage pattern didn't match implosion. It matched compression, followed by an abrupt expansion as if the object had been crushed and then freed. No known marine event could produce that pattern. No natural predator could apply pressure in that way, and no geological process could explain the absence of heat damage. The fragment sits now in a university archive, catalogued, studied, inconclusive. The rest of the drone has never been found. Some believe it lies in pieces at the bottom of a trench we have yet to map. Others believe it still drifts, deeper now, beyond telemetry, beyond reach. But the oddest theory of all comes not from oceanographers, but from linguists. Shortly after the transmission, when Sea Drone 37 briefly resurfaced near Tonga, researchers ran a spectral analysis of its final handshake. The short data burst that included the video frame. Hidden in the metadata was an acoustic signature, not human, not mechanical, a pattern. 5 tones, rising in pitch, followed by silence. Repeated once, then gone. It was dismissed at first as compression error, but the pattern didn't match any known glitch algorithm. It was structured, deliberate, almost intentional. One researcher likened it to a sonar beacon, another to an encoded handshake protocol, something akin to a digital knock seeking entry. But to where, and who, or what, might answer. The ocean is not empty. It is filled with movement, pressure, time, and memory. Sea Drone 37's journey, from precision-guided dive to inexplicable disappearance, is not just a technical anomaly. It is a story of the limits of observation, of the things we think we can control, and the places that quietly remind us we cannot. The Kermadec Trench is still there, unmapped, uninviting. And in its shadows, something waits. Perhaps just silence, perhaps something more. 9 days, 2,300 miles, one frame. That's all we have. But it's enough to raise the question that won't go away. What did Sea Drone 37 see? What saw it, and why? Did it resurface? Just once, just long enough to remind us we are not alone in the deep, and some things, even without sound, still find a way to speak. Story 7. The Deepwater Dagger, an unmarked wreck in the Coral Sea. From the vanished drone signal near the Kermadec Trench, to the unnerving moment it blinked back into existence, 2,300 miles away and 9 days later, we're left with a chilling sense of scale, of how vast the ocean truly is, of how even precision-built machines, guided by satellite and sonar, can be swallowed by that vastness, and how sometimes, without warning, they return. But not all of the ocean's riddles drift silently through the water. Some lie still, waiting to be found, in coral-choked canyons and silted shelves, where the seabed folds into itself like the pages of a forgotten book. That's where our next story begins. Not with a signal, but with a shadow, a shape half seen beneath the coral, a shape that shouldn't be there, and one no nation has ever claimed. This is the mystery of the Deepwater Dagger. It begins in the Coral Sea, a place as beautiful as it is unforgiving. Stretching off the northeastern coast of Australia, the Coral Sea is a vast, restless expanse of tropical ocean. Its waters are warm, turquoise in the shallows, sapphire in the depths. Beneath the surface lie thousands of reefs, many unmapped, and channels so deep they touch the edge of the Earth's crust. It's a place where colour and silence intertwine, where divers drift over shelves of staghorn coral. And then, just meters away, the seafloor drops out into blackness. For marine biologists and oceanographers, the Coral Sea is a living laboratory. But for deep-sea divers, especially those who stray too far from the main routes, it's something else entirely. It's a graveyard. World War II left dozens of wrecks scattered across this part of the ocean. From American bombers to Japanese submarines, the seabed is littered with fragments of war. Many of them are well documented, protected, even memorialized. But this one wasn't. The first known sighting came in 2011, though some claim they heard whispers of it long before. A group of technical divers from Queensland, testing a new trimix blend for deep descent, were scanning an unmapped area east of Holmes Reef. Their goal was simple: find a new reef wall, test equipment, get back by dusk. What they found instead changed everything. At 112 meters down, beyond the reach of sunlight, one of the divers saw it. A line in the silt, sharp, unnatural. He thought it might be part of a reef ledge until he touched it. Metal, smooth, cold, angled. He followed it with his gloved hand. The line extended outward, curving slightly, then disappearing into coral growth the color of old bone. They spent only minutes with it, their oxygen carefully measured. But even in those minutes, it was clear. This wasn't a natural feature, and it wasn't a World War II wreck. There were no rusted rivets, no barnacle-covered conning tower, no signs of battle damage or torpedo tubes, just a shape, too sleek, too deliberate, and too intact. They surfaced shaken, not by fear, but by confusion. The coordinates were noted. The photos, dim, taken through murk and silt, were inconclusive. At first, they told no one. In the world of private diving, discoveries like this are currency. You don't broadcast a find, not until you know what you found. Months passed, then a year. A second dive followed, better prepared. Longer exposure, more equipment. A small ROV, tethered by cable, was lowered into the site. The footage it brought back revealed more than the divers expected. A hull, nearly 70 meters long, mostly buried under coral accretion and silt. The shape was unmistakable. It was a submarine, but not one that matched any known model. The hull lacked hatches. The rudder structure was unusual, not at the stern, but integrated into the lower fin like a diving bell. The metal was dull, not rusted, as if it had been treated with something resistant to corrosion. And then there was the entry point. Toward the bow, half covered by sea fans and sand, was an opening. A circular port, too small to be a torpedo bay, too high for a ballast vent. It appeared sealed. They didn't breach it then, but the mystery had taken root. Eventually, word got out. An oceanographic team from New South Wales learned of the site and offered formal assistance. With university backing, they were able to fund a deeper survey, this time with side-scan sonar and a pressurized submersible. The submersible arrived in 2014, and what it found inside the wreck changed the story completely. The hull was indeed metallic, some alloy blend not immediately recognizable. No naval records matched the design. No known submarine, American, Soviet, Chinese, British, or Japanese, had ever used such a configuration. But what caught the scientists' attention wasn't the outside. It was what they found inside. The submersible's probe arm reached through a broken section of the mid-hull, widening the breach. A camera followed, trailing light. What the light revealed was startling. Equipment, modern, clean-lined, still intact. Not the dials and gauges of mid-century submarines, but sleek, panel-based systems with rounded corners. Control surfaces with no obvious interface, just smooth black glass. Consoles that blinked to life when brushed by the ROV arm. But the strangest part? The writing, or rather, the absence of it. Across every surface, every screen, every console, every label, were symbols. Not Cyrillic, not Chinese, not Latin, not Arabic. They were arranged like language, but unreadable. Curving forms, broken circles, three-part glyphs that repeated in strange, rhythmic patterns. At first glance, they looked almost artistic, like decorative motifs. But when run through linguistic software, patterns began to emerge. Repetition, syntax, structure. It was a language, but no known tongue, and certainly not one used by any modern nation. The ROV collected footage. Samples of the outer hull were extracted for analysis, and then, quietly, the entire project was paused. Not ended, just suspended. The reasons given were logistical: funding delays, equipment maintenance, weather patterns. But insiders claimed something else happened, that someone, government or private, had intervened. The team leader left his post 2 months later. The footage was archived. The site was never revisited under that program. But the divers, the ones who found it first, kept diving. They brought others, quietly, carefully, independent explorers, linguists, engineers. And the more they explored, the more questions surfaced. Inside the hull, deeper now, through the port access, they found what looked like seating. Not chairs exactly, not human-sized. Shorter, narrower, sloped at a strange angle, as if designed for a different posture. The seats were molded into the floor. No straps, no belts, just concave impressions, each aligned with a console that still pulsed faintly with light. No bodies were found, no bones, no fabric, no gear, just the quiet hum of systems long powered down. And yet, the lights, they still glowed. How? There was no visible power source, no reactor, no batteries that could last this long. And the wiring, where visible, was strange, flat, thread-like, embedded into the walls themselves like veins. Whatever this vessel was, it was never meant to be found. And yet, it had been. Theories spread, at first cautious. Could it be an experimental craft? A Cold War-era prototype, lost and disavowed? But none of the configurations matched. No country had developed submarines with seamless hulls and gesture-sensitive consoles in the early 2000s, let alone the 1970s or before. And the language, if it was a language, didn't correspond to any cipher, any constructed alphabet. Not even glossolalia could explain its structured precision. Some suggested reverse-engineered tech, recovered elsewhere, buried here, tested and abandoned. But abandoned how? And why in the Coral Sea? Others turned to more fringe ideas, that the vessel wasn't from Earth, that the symbols were not human constructs, that the seating, the posture, the scale of the craft suggested something not like us. But even these theories felt too clean, too theatrical, because nothing about the wreck screamed alien. It was too familiar. Not alien, but adjacent. Like a shadow of something we might have built in another timeline. Some researchers, borrowing from linguistic archaeology, began comparing the glyphs to proto-writing systems: Sumerian cuneiform, Indus Valley script, Linear A, all undeciphered, all long dead. And while no direct match was found, the feeling of the symbols, the repetition and balance, echoed something ancient, as if whoever, or whatever, had made this craft, understood language, but not ours. And then came the final mystery: the dagger. It wasn't actually a weapon, not in the conventional sense. It was a shape, sleek, sharp, embedded at the very tip of the bow. A fin, no longer than a human arm, etched with the same unreadable glyphs, but it protruded like a blade, angled forward, fused to the hull. When scanned with sonar, it gave back strange returns, as if hollow, but full, as if absorbing sound. Divers who touched it described a feeling, not pain, not vibration, but pressure, like holding a tuning fork in still air. They called it the Dagger, and from that name, the wreck got its own title, the Deep Water Dagger. Today, its location is known only to a handful. The Coral Sea is vast, and shifting sand and coral growth conceal more than they reveal. But the wreck is still there, still glowing faintly in the dark, still unclaimed, still unexplained. And no country, not one, has ever acknowledged its existence, not in statements, not in silence, not even to deny it. That, perhaps, is the strangest part, because if it was ours, someone would have said so. And if it wasn't, then we're left with a deeper question, one the divers still ask on quiet nights, when the ocean is still and the mind wanders. If it's not ours, and not theirs, then whose is it, and what else might lie beneath the sea, still watching, still waiting, still listening, silent, except for the faint hum that never goes out. Story 8. The Vortex Echo. From the silent hum of an unmarked wreck in the Coral Sea, its language unknown, its origin unclaimed, we turn now to something far stranger. Not a vessel, not a relic, not even something seen, but something heard. It began with a sound, a soft, wavering ripple that drifted across the Pacific and slipped through submarine hydrophones like a ghost brushing past a door. It didn't arrive all at once. It crept in slowly, barely perceptible at first. But what made it different, what made it rise above the background roar of the ocean floor, was its rhythm. A pattern. Every 13 hours, without fail, the sound would return. And what it played was unlike anything scientists had ever heard. To some, it resembled human speech, only distorted, twisted, and reversed. This is the mystery of the Vortex Echo, a looping, speech-like signal that emerged from the deep Pacific in 2012 and never stopped coming back. The world beneath the waves is a symphony of chaos. Currents groan, volcanic vents hiss, whales call out in low, mournful tones that can travel for hundreds of miles. Submarine hydrophones, built to capture and analyze these noises, are usually overwhelmed with sound. Most of it is noise, unfiltered, formless, natural. But in April 2012, researchers working as part of an ocean acoustic survey off the central Pacific Basin noticed something strange. A low-pitched signal just on the edge of perception. It seemed out of place, structured, intentional. At first, it was thought to be an anomaly, a bit of signal drift, perhaps a malfunction in the recording equipment. But as data from neighboring hydrophones came in, it became clear this was no accident. The sound was real. It started as a low-frequency rise, followed by what sounded like reversed phonemes. The clipped syllables of human language played backward and slowed to a crawl. Then, silence. Then, the cycle would begin again. The full loop lasted precisely 2 minutes and 17 seconds. And every 13 hours, it would begin anew. What was stranger still was the apparent directionality. Triangulation efforts pointed to a consistent source, somewhere within the deep waters of the Pacific Ocean, a region spanning between the Vortex void overhead and the ocean floor beneath the Clarion-Clipperton zone. In astronomical terms, the Vortex void is a vast, empty region of space, nearly 330 million light-years across. It is, quite literally a hole in the known universe. The nickname Booter's Echo wasn't official, but it stuck. Not because of the celestial connection, but because of the feeling it gave the scientists who first heard it, that something had spoken from the deep, and that it had echoed back. Acoustic specialists began to examine the waveform. It wasn't mechanical. There were no repeating pings, no signs of sonar, no metallic resonance like you might expect from a malfunctioning buoy or a submarine transponder. And yet it didn't match any known animal vocalizations either. Not even the complex clicks of sperm whales or the long-range singing of blue whales came close. The closest analogue, unsettlingly, was human speech. When the sound was digitally reversed and pitch-adjusted, parts of the signal bore a passing resemblance to syllables, not language, but almost. It was as though someone or something were trying to speak using the architecture of human communication, but backwards, slurred, as if mimicking us from a distance or practicing. What came next was even stranger. After weeks of analysis, researchers isolated a consistent structure in the signal's timing. It did not just repeat every 13 hours, it synchronized. With what exactly is still debated. Some noted that the timing appeared to correlate with a tidal pattern, though not one directly linked to surface waves or the moon's gravitational pull. It seemed to follow a deep oceanic resonance, a pressure wave moving across the Pacific thermocline. Others speculated it might be related to diurnal migration patterns. Every night, billions of small sea creatures rise toward the surface and sink back down before dawn. Known as the largest migration on Earth, it moves like a living tide. Could the signal be following that movement? Still others suggested something more chilling, that the 13-hour cycle wasn't based on Earth time at all, that it was off, by minutes, consistently. If true, that would imply the signal was following a different rotational reference, something not tied to the sun, something alien to the rhythms of our planet. Attempts to map the source proved elusive. The deeper they looked, the less they found. It was like the signal was coming from below the seafloor itself. A pressure wave, perhaps, echoing off some cavity or ancient subduction zone, or from something embedded. Theories soon poured in. One proposed that it might be a natural acoustic resonance trapped within a seamount or trench. Certain undersea topographies can behave like bell chambers, amplifying even faint vibrations into audible harmonics. But if that were the case, where was the initiating source? Another theory posited a rogue underwater research drone, an autonomous device that had gone off mission and was broadcasting a corrupted or looping distress call. But exhaustive checks of all known international assets in the area revealed nothing. The US Navy, whose SOSUS network once spanned the Pacific, declined to comment. Privately, some marine biologists speculated the signal might belong to a new species. Not a fish, not a whale. Something deep-dwelling, something ancient. It wouldn't be the first time. In 1997, a powerful, ultra-low-frequency sound called the Bloop was captured off the southern Pacific coast. At the time, it defied classification, its profile too organic to be geologic, too massive to be biological. Years later, it was tentatively linked to ice quakes. But even today, some remain unconvinced. Could the Boater's echo be another such anomaly? Or could it be something different altogether? A communication? A broadcast? A warning? When news of the signal quietly reached civilian scientific circles, a few independent labs attempted to replicate the findings. Hydrophone archives from 2012 were scoured. In at least 3 locations across the Central Pacific, the same 13-hour loop was found, all identical. It wasn't a local echo, it was global. And here's where things become more than strange. In late July of that same year, a research vessel from the Oceanic Acoustic Monitoring Initiative, OAMI, reported a critical malfunction in its deep-sea tethered platform. The platform had descended to a depth of over 4,000 meters when the onboard hydrophone began registering sharp pulses. 12 of them, each one increasing in pitch. Each one spaced precisely 11 seconds apart. Then, silence. When the platform was recovered 2 days later, its lower structure, a titanium-caged sensor array, was crushed, not imploded. Crushed, not by pressure, but by force. External. It looked, in the words of one technician, like something had grabbed it. The incident was not reported publicly, but in a leaked internal document, the pulses were referred to by name, preceding events to booters. Whether that was a coincidence or confirmation, no one knows. Later that fall, the signal changed. On October 19, 2012, the echo failed to appear at its scheduled interval. Acoustic monitoring stations logged only ambient noise. Then, 14 hours later, it returned. Different. The waveform was inverted. It was no longer backward, it played forward. And this time, it sounded clearer. Still not intelligible, still not language, but closer, more confident, as if whatever was speaking had refined its method, had learned. For 2 weeks, the forward signal continued. Then it stopped entirely, and the Pacific went quiet. The phenomenon has not repeated since. To this day, no official agency has offered an explanation. Some believe it was a classified test, a deep-sea acoustic calibration for submarine navigation or covert communication. Others argue it was an experimental SETI initiative, reversed, not listening to space, but to the sea. Searching not for extraterrestrials, but for unknown terrestrials. Entities that might dwell below, rather than above. One hypothesis suggests the sound originated from a long-dormant undersea structure, perhaps a remnant from Earth's deeper past, a relic, a beacon, something that reactivated due to tectonic pressure or environmental shifts. And then there are those who believe the signal wasn't meant for us at all, that we just happened to overhear it. A transmission not directed upward, but laterally, across the deep, from one unknown to another. And we, listening on our fragile human microphones, were nothing more than eavesdroppers. There are other mysteries, of course. Hydrophone anomalies abound. From the upsweep to the Julia Sound, the ocean continues to emit strange, unexplained noises. Most are chalked up to ice friction, thermal activity, or seafloor movement. But the boater's echo stands apart, because it wasn't just sound, it was structure and rhythm, and the unmistakable shadow of intent. Somewhere out in the deep Pacific, between the trenches and the silence, something called out. Not once, but again and again. And then, once it was certain it had been heard, it changed. Was it a voice? A warning? A call? Or was it the echo of something much older? Something that sleeps beneath the ocean floor, stirring every 13 hours to repeat a message meant not for us, but for something we do not yet understand? No one can say for sure. But those who heard it still remember the reversed syllables, the cold regularity, and the sense, impossible to shake, that it had always been there, just waiting for someone to listen and wondering what we might say back. Story 9. the Sakhalin anomaly. From the warped rhythm of the boat's echo, a looping message hidden in sound, pulsing backward through the Pacific every 13 hours. We now turn to another anomaly. But this one didn't call out across the water. It burned. It smoldered, unseen, beneath thousands of feet of ocean, in a place with no volcanoes, no vents, and no reason to produce heat at all. It began, like many such mysteries do, with a routine survey. A Russian submarine, unmanned, precise, built for research, scanning the cold seabed near Sakhalin Island in the Sea of Okhotsk. What it found should have been impossible. Not just heat where there should be cold, but something else. A signature, a distortion, and perhaps most disturbingly, a man changed by proximity. Let's dive into the unsettling mystery known today as the Sakhalin anomaly. The Northern Pacific is a region of cold seas and colder secrets. To the east lies the Kamchatka Peninsula, studded with volcanoes and snow-blanketed ridges. To the west, the vast expanse of Siberia. And nestled in between, floating just off the mainland, is Sakhalin, Russia's largest island. It's a long, narrow landmass stretching over 600 miles from north to south, with dense forests, abandoned Japanese settlements, and a coastline battered by wind and time. Much of its history is a story of dispute, claimed by both Russia and Japan across centuries of shifting borders and war. But beneath the island, beyond the reach of any cartographer's pen, lies something far older. The Sea of Okhotsk that surrounds Sakhalin is not an easy place to explore. The water is cold, the weather often violent, and the winter months bring thick layers of sea ice that choke off entire regions for weeks at a time. Visibility below the surface is limited. The currents unpredictable. This is not a place where casual diving takes place. But for scientists, it's a frontier, especially in the pursuit of offshore gas and oil. And in 2015, one such survey team from a Russian geological institute launched an underwater mapping expedition designed to chart the thermal structure of the seafloor just east of Sakhalin's southern edge. The submarine used was one of Russia's newer hybrid survey drones, equipped with deep imaging sonar, heat mapping arrays, and high-resolution bathymetric cameras. It had no crew aboard, but it relayed its telemetry live to a monitoring vessel above. At first, the data came in just as expected. Cold ocean water, standard silt layers, sedimentary ridges traced by centuries of underwater movement. There were signs of past glacial action, some minor tectonic faults, nothing out of the ordinary. But then, the drone passed over a narrow trench, only about 20 meters wide, etched into the flat seafloor like a cut, and the temperature readings spiked. Within seconds, the heat sensors began flagging anomalies, not gradual changes, but sudden, defined increases of nearly 120 degrees Celsius localized to a single patch of seabed. There were no vents, no lava flows, no volcanic ridges. The nearest tectonic activity lay hundreds of kilometers to the south. The heat signature didn't radiate outward like a thermal bloom. Instead, it seemed to form a geometric pattern, tight, almost surgical in its symmetry. To the operators on the research vessel above, it looked less like a natural formation and more like a grid. Perplexed, the team initiated a slow circular scan. As the drone orbited the site, its sonar began picking up reflective distortions in the trench wall, as if something below the sediment was scattering the pulses unevenly. The images that came back were faint, outlines more than objects. But there were shapes beneath the silt. Angular depressions, right-angled seams, something buried. For hours, the team worked in silence, combing through the data stream. And then, contact was lost. The drone didn't crash. It didn't shut down. It simply stopped transmitting. By the time the tethered cable was reeled back in, only the primary hull remained. Its camera array, gone. Its rear ballast system, sheared off. The heat sensors, the mapping gear, all of it stripped as if torn by immense force. Yet the hull itself was not crushed, not imploded. It had not suffered pressure failure. It had been dismantled. The operators were stunned. The vessel had been designed to endure depths 3 times deeper than the survey zone. There was no known creature large enough to attack it, no geological explanation for such surgical damage. And then came the aftermath. Among the research team on board the surface vessel was a technician named Mikhail Astrov. He had overseen the data stream during the initial anomaly detection. For over 90 minutes, he had watched the infrared feed cycle between stable readings and violent fluctuations. He had noted the grid. He had highlighted the trench distortion. And when the drone was recovered, or what was left of it, he had helped catalogue the damage. According to other crew members, Mikhail was calm at first, quiet, focused. But within a day, something changed. He began asking strange questions about sound frequencies, electromagnetic spikes, and vibrational echoes that had never been part of the mission. He stopped sleeping. At night, he was heard muttering in his cabin, not in Russian, but in a clipped staccato rhythm no one recognized. The ship's medic was called in. Mikhail resisted treatment, insisting that the heat signature had spoken to him, that beneath the seafloor lay something not dead, only sleeping. He began drawing diagrams, circular patterns with intersecting lines, annotated with numbers that made no sense. Eventually, he was sedated and flown back to the mainland. His family, later interviewed by a private investigator years after the incident, claimed he never recovered. Mikhail suffered from near-constant migraines. He reported auditory hallucinations, low, humming tones that increased in pitch whenever he was near water. His health deteriorated, and he withdrew from public life entirely. No official explanation was ever given. The survey data was classified, and the site, coordinates redacted from public records, was never revisited, or so it was claimed. But fragments of the incident began to leak. A retired Russian oceanographer, speaking anonymously to a European documentary team in 2018, described hearing whispers of a thermal phantom east of Sakhalin, an event that triggered a shutdown of multiple exploratory grants in the region. He recalled hushed warnings from superiors to avoid grid trench sectors in future mapping runs. And then there were the satellite readings. In 2016, a private weather monitoring firm based in Norway recorded an unusual heat bloom in the Sea of Okhotsk, a vertical column of slightly elevated surface temperature only 1 kilometer across, lasting just under 6 minutes. It didn't match any known upwelling or marine current. No storm activity was present. No seismic event was recorded, but it aligned precisely with the rumored location of the Sakhalin Trench anomaly. So what exactly happened on the seafloor in 2015? And what could explain the damage to the drone, the hallucinations of the technician, and the refusal of Russian authorities to acknowledge the incident? There are several theories. The official stance, when pressed by journalists, is that the drone suffered a pressure-related malfunction near a minor hydrothermal vent, that the heat readings were the result of deep subsea gas migration, a common phenomenon near methane hydrate deposits, that the technician's illness was psychological, stress-induced, exacerbated by cabin conditions and overwork. But this theory doesn't hold up. The Sea of Okhotsk has been extensively mapped for hydrocarbon exploration. No major hydrate fields exist near the southern trench in question, and methane releases don't produce symmetrical grid-like heat patterns, nor do they shear mechanical equipment without explosive signatures. A second theory suggests military interference. Some believe the drone may have stumbled upon a classified installation, a submarine testing ground, or a deep-sea sensor array, and was disabled deliberately. The damage, they argue, could be consistent with active deterrent systems. Mikhail's breakdown? Perhaps exposure to low-frequency transmissions, or even a cover story for exposure to classified hardware. But there are problems here too. The drone wasn't navigating near any known military zone. The telemetry logs were live-streamed. Multiple external research partners were watching the feed in real time. And if it was simply a case of restricted waters, why not quietly delete the data and move on? Why redact the coordinates from public oceanographic charts? Why cancel unrelated projects? Why leave behind so many loose ends? Which brings us to the third theory, the most speculative and the most unsettling. Some oceanographers, operating well outside mainstream academia, believe the Sakhalin anomaly may represent something unknown beneath the seabed. Not alien in the science fiction sense, but alien to our understanding of geophysical structures. A buried object, or perhaps a buried system. These researchers point to the geometry of the heat signature, the grid formation, the sudden onset, the sharp temperature drop-off outside the anomaly's boundary. They note that the shape resembled no known natural formation, and that sonar reflection patterns hinted at metallic density beneath several meters of silt. In their view, the drone encountered not a vent, but a kind of seafloor architecture. Something dormant, something encased. The trench, they argue, is not the anomaly. It's the edge of it, a boundary, a lid. And when the drone crossed it, the system beneath reacted. One speculative paper published anonymously in an online research archive described it as a latent geothermal relay, designed to regulate internal energy without surface detection. It suggested the grid could be a form of thermal venting, not accidental, but calibrated. As for Mikhail, the paper theorized electromagnetic harmonic interference, a pulse triggered by the drone's sonar, broadcast back in subaudible frequency, directly into the ship's instrumentation. The human brain, after all, is vulnerable to sustained low-frequency vibration, especially when amplified by water, especially when exposed for 90 uninterrupted minutes. The symptoms, migraines, auditory hallucinations, sleep deprivation, align closely with known effects of infrasound exposure. But the rhythmic speech, the diagrams, the claim that something had spoken to him, that remains harder to explain. The crew members interviewed after the mission reported no such symptoms. Only Mikhail had been affected, and only Mikhail had remained locked to the thermal feed for the duration of the anomaly. Some researchers now refer to it as a form of induced pareidolia, the brain projecting order onto noise. Others aren't so sure. A fourth, even more fringe theory posits that the site near Sakhalin is not geological at all, but biological. Not a buried structure, but a dormant organism. An entity that has grown crusted over with sediment and time. One that exists beneath the seafloor, radiating heat in cycles, perhaps seasonal, perhaps triggered by acoustic intrusion. They point to the grid pattern not as architecture, but as vascular, a circulatory trace. The sonar distortions, resonant cavities, the heat spike, a metabolic response. In this view, the drone didn't discover a trench. It touched a nerve. And Mikhail? He was the canary in the coal mine, the first to hear something ancient stir. No hard evidence supports this theory, but in the absence of a return mission, nothing can fully disprove it either. And that is perhaps the most haunting aspect of the Sakhalin anomaly. Not the heat, not the missing drone equipment, not even the whispered descent of a technician into obsession, but the silence that followed, the refusal to investigate further, the redacted logs. The ocean, after all, is not merely a place of depth, it is a place of delay. Data takes time to surface. Stories take years to coalesce. Whispers ripple outward like waves. And in the case of Sakhalin, something rippled, something deep. But then, nothing. No follow-up missions, no cross-national inquiry, no public explanation. Only a line of temperature readings that ends abruptly, and a man who no longer speaks. What sleeps beneath Sakhalin? A fault line, a relic, a system, or something beyond our framework entirely, something not meant to be found? We may never know, because the drone didn't return whole, and the man who listened never stopped hearing. Story 10. The Himera Ridge displacement. What happened to the man who listened and never stopped hearing? It's a question that echoes across the depths, where pressure crushes steel and time seems to stall. But not all deep-sea mysteries whisper their secrets in heat signatures or distorted signals. Some announce themselves more violently, not in flickers of temperature or elusive sonar, but in brute force. Force that moves through water without form. Force that should not exist in the stillness of the deep. We now turn our attention to the Himera Ridge, an ancient fracture along the Sicily-Malta escarpment, and a modern encounter that left one submarine changed forever. Not missing, not destroyed, but bent, as if it had been pushed from the side. This is the mystery of the Himera Ridge displacement, and it begins, as many of these stories do, in calm waters. The Strait of Sicily lies between the toe of the Italian peninsula and the island of Malta, a shallow but turbulent crossroad of tectonic drift, deep water channels, and centuries of warship wreckage layered beneath silt and salt. It's a place where the Mediterranean narrows, a geological bottleneck where Africa and Europe creep closer each year, pressing like invisible plates in a game of ancient, grinding patience. The seafloor here is complex, not the smooth, sandy bottom of beachgoer maps, but jagged terrain shaped by millennia of underwater landslides, crustal uplift, and faulting. And running through it all is the Sicily-Malta escarpment, a vast undersea cliff that plunges several kilometers at its steepest points. From above, it's barely visible, but beneath the surface, it is a world of sudden depth and buried motion. Italian naval surveys have long monitored this zone, not only for geological shifts, but for potential seismic hazards to Sicily and southern Italy. Over the years, it's also become a test bed for submarine deployments. Quiet, deep, and unpopulated, this corridor is ideal for running stress tests, signal experiments, and silent drift simulations. The kind designed to evaluate crew reaction to engine-out scenarios or unpowered descent maneuvers. On April 5, 2003, the Salvatore Todaro, a Todaro-class diesel-electric attack submarine newly commissioned by the Italian Navy, departed from its base near Augusta. Its objective was routine: descend into a trench west of Himera Ridge, run passive drift mode for 6 hours, monitor hull stress and instrument response, then return. The descent went as expected. Weather was calm, sea state minimal. At 11:42 a.m., the submarine powered down to minimum engine output, allowing the vessel to enter what's referred to as buoyant glide, a slow, gradual sink that uses the natural density of the vessel to slide along thermal gradients. It's not true freefall, but close. The kind of maneuver that simulates stealth infiltration while collecting valuable acoustic and pressure data. At 12:03 p.m., depth sensors showed the vessel approaching the upper edge of the escarpment. This is where things started to go. Strange. At first, it was a vibration, faint, almost imperceptible, just enough to rattle a pen loose from a bracketed clipboard near the communications terminal. Then came the drift, a gentle veering off-axis. The crew adjusted ballast slightly to correct the deviation. Instruments recalibrated. Stability returned. But 3 minutes later, the entire vessel jolted. Not from beneath, not from above, from the side. Imagine being inside a steel cylinder 230 feet long and feeling it shift, not from a wave or a swell, but from an invisible shove, as if the water itself had briefly moved sideways. The logs from that hour tell a story of controlled confusion. At 12:06 p.m., the command officer ordered a full system diagnostic, suspecting a mechanical fault in the lateral propulsion. But nothing had activated. No propeller wash, no ballast release, no recorded thrust, just a sudden motion, as if the sea had changed its shape for a moment. Then the pressure alarms went off. Compartment 3, midsection, port side, showed a rise in hull strain. Not catastrophic, but irregular. One of the weld seams near the secondary sonar dome had begun to warp, a slight but measurable buckle, as if something had flexed the outer shell from an unexpected angle. The crew remained calm. There was no flooding, no decompression. All systems were responsive, but the dive was aborted. The submarine surfaced slowly, running silent diagnostics all the way up. Upon return to port, naval engineers conducted a full external survey. What they found was subtle, but deeply unsettling. The port side outer hull, just above the forward stabilizer fins, displayed a 2-meter-long indentation. Not a puncture, not a gash. A dent, smooth at the edges, compressed inward, as if something massive and soft had pressed against it and then released. Sonar logs showed nothing. No contact event, no echo return, no acoustic anomaly. Just normal readings until the moment of displacement. Some of the crew described it as being caught in an undertow without warning, but horizontally. One officer likened it to a giant, slow breath, like the sea inhaled, and we were caught in it. The official report called it an unexplained lateral force incident. Privately, others called it something else, an invisible current, a pocket of pressure, a field. But the most whispered word was push. So what could cause a submarine, a vessel engineered to resist the crushing forces of the deep, to move sideways without propulsion? To answer that, we need to examine what's beneath Himera Ridge. The escarpment itself is a faulted boundary, a geological scar where the African plate is slowly slipping beneath the Eurasian plate. It's part of a broader tectonic zone that includes the Calabrian Arc and the Ionian subduction complex. These are not static features. They are in motion, millimeters per year, yes, but with deep accumulations of stress and occasional seismic bursts that reshape the terrain in sudden, dramatic ways. Some researchers believe that undersea landslides in this area, known as slump events, can create localized displacement of water masses. If a large enough volume of sediment shifts rapidly, it can displace water laterally, creating what is effectively a horizontal shockwave. But there's a problem with that theory. There was no seismic activity recorded that day. No tremor, no microquake, and no evidence of turbidity plume, the underwater equivalent of a dust cloud, which would be expected after such a landslide. Satellite altimetry detected no anomaly in surface current, and bathymetric scans taken 2 days later showed no sediment movement at the incident site. So if not a landslide, then what? Some turn to the idea of internal waves, invisible rivers of motion that travel not on the surface, but within the ocean itself. These waves form at the boundaries between water layers of different temperature and salinity. Unlike surface waves, they can travel vast distances undetected by satellite or eye. They can reach hundreds of feet in height and move at slow speeds, pushing everything in their path with silent force. Could the Salvatore Todaro have intersected such a wave? In theory, yes. But again, the readings don't match. Internal waves leave a thermal signature, and the sub was equipped with sensors specifically to detect thermocline shifts. There was no such shift recorded that day, no change in salinity, no fluctuation in water temperature. Whatever moved the submarine left no trace. That's where the theories begin to drift. Some speak of dead water, a phenomenon documented in fjords and enclosed basins, where a layer of freshwater traps denser saltwater beneath, causing vessels to slow or veer without obvious resistance. But dead water affects surface ships, not subs operating at depth, and certainly not in the warm, open zones south of Sicily. Others wonder about magnetic anomalies. The Himera Ridge sits along a known transition zone in crustal composition. Deep within the Earth, certain types of ultramafic rock can carry remnant magnetism. Under the right conditions, these can distort local magnetic fields, enough to interfere with compass readings or even electrical systems. But the Todaro was not relying on magnetic navigation at the time. Its systems were inertial, tracking motion through internal sensors, not compass bearings. Still, could a strong enough anomaly create a kind of magnetic pressure? The idea is not mainstream, but in 2007, French oceanographers in the Azores documented a strange oscillation in magnetometer readings that coincided with unexplained drift in a free-floating deep submersible. The data was inconclusive. The effect was brief, but the timing raised eyebrows. Then there's a more speculative avenue, one that veers into the uncharted. Some suggest the possibility of acoustic resonance, low-frequency vibrations that build within underwater canyons, creating zones of unusual pressure. In theory, a submarine caught in such a standing wave could experience uneven force distribution across its hull. It's a stretch, but the Sicily-Malta escarpment is known to reflect and refract sound in unpredictable ways. Early NATO experiments with sonar baffling were conducted in this region precisely because of its irregular acoustic profile. Still, no known resonance pattern has ever generated a sideways pulse strong enough to warp a hull. And so, we return to the shape of the dent, to the curve, the compression, and the eerie precision of its edges. Naval engineers called it biologically improbable. The indentation didn't match the profile of any known marine animal. It was too wide for a shark, too uniform for a whale strike, and the lack of external tissue residue, skin, oil, or impact abrasion ruled out a collision with any soft-bodied creature. Nor did it resemble damage from netting, debris, or subsurface wreckage. It looked imposed, deliberate. Yet the sub was alone in the area. No other vessel was recorded within 50 kilometers, and the nearest undersea cable, often responsible for strange readings when under tension, was over 90 nautical miles away. So what happened to the Salvatore Todaro? What pressed against its steel skin and vanished without sound? Theories grew quiet after that. The official file was closed later that year. The damage was written off as unexplained environmental force, consistent with localized hydrokinetic displacement. But that phrase means very little. To this day, the crew remembers something else. Not noise, not light, but pressure. A moment of stillness, then a sudden shift. One sonar officer claimed he felt it in his teeth, a low, pulsing tension just before the jolt. Another said it felt like sliding sideways inside a dream. One junior technician, off duty at the time, described a sensation of weightlessness, followed by a pull, like the ocean had taken a breath, and then released it. There are rumors, always unofficial, that this wasn't the only incident of its kind. In 1998, a Greek survey drone operating near the Hellenic Trench reported an uncommanded lateral drift before losing contact. Its data logger was recovered days later, showing minor hull deformation along its starboard side. In 2011, a French Navy sub in the Ionian Sea aborted a dive after a sudden axis deviation led to strain in one of its aft stabilizers. Neither incident was made public at the time, but the similarities are there: a push, a warp, a silence, and in each case, nothing seen, only a change, a shape left in metal, a memory left in crew. Some believe these are echoes of something geological, ancient shifts stirring beneath new crust, altering the shape of water in ways we don't yet understand. Others believe they are encounters, not with machines, but with motion, patterns, fields. The sea, after all, is not empty. It is full of gradients, pulses, and tides within tides, and perhaps, just perhaps, something moves through those layers, not as creature or craft, but as presence, not always seen, but sometimes felt. And when it brushes past us, with just enough force to leave a mark, we call it unexplained. The Himera Ridge remains quiet now, but the dent on the Todaro still exists, photographed, measured, and stored in an archive. It tells no story. It offers no answer, but it is real. And so is the silence that followed it. What moved that submarine? What pressed inward with invisible force? What made no sound and left no trace? The Mediterranean holds many histories, but some are not buried in ruins or drowned in wrecks. Some move beside us, hidden in current, in silence, and in steel. And not all of them are gone. Some are still passing by. Story 11. The uncrewed ascent of Vortex 9. But not all sounds from the deep come in the form of unearthly moans or distant vibrations. Not all anomalies announce themselves in sonar. Some arrive quietly, returned, not recovered, resurfaced, but not escaped. and some are found floating. From the invisible hand that pressed against the hull of the Todaro, we now follow a newer silence, one that surfaced with no struggle, no signal, and no explanation. It is the story of a British submersible, Vortex 9, and its final dive in 2022. A dive that began with routine testing and ended with an empty cabin, a blank screen, and a question that no one has been able to answer. What happened to the crew of Vortex 9? Why did the sub return without them? And what caused its instruments, everyone, to shut off? Let's descend into one of the strangest disappearances in recent maritime history. The story begins in the North Atlantic, in waters off the coast of Scotland, not far from the Hebrides, a place where wind-scoured cliffs meet restless sea, and where, on quiet days, the water lies deceptively calm. It was here, beneath these grey waves, that the Royal Maritime Research Institute had been conducting deep-sea trials for a new class of research submersibles. Small, agile, and designed for high-pressure endurance, these vessels were meant to gather data in difficult-to-reach regions of the continental slope, especially where larger crewed subs could not maneuver safely. Vortex 9 was the 9th prototype in the line, a sleek, titanium-hulled sub built for endurance. Unlike its predecessors, it had undergone several retrofits, including electromagnetic shielding, advanced inertial navigation, and a custom panoramic viewport shaped in a subtle arc, designed to mimic human field of vision for psychological stability during long dives. It had completed 6 successful test dives before the incident, all within normal operating parameters, all logged, signed, and reviewed. There was no reason to believe the 7th would be any different. The dive took place on September 2nd, 2022. The weather was steady, skies overcast, mild current, nothing unusual. Vortex 9 launched from the support vessel Hesperus at 7:14 a.m. local time. On board were 3 crew members: Captain Lionel Harrow, veteran of over 40 deep-sea missions, calm, methodical, known for his precision and measured speech; Dr. Ava Selwyn, marine biologist and neural mapping specialist. She had been studying patterns of fish movement near anomalous magnetic gradients. And finally, Rakesh Sinha, systems engineer responsible for real-time data relay and sub-diagnostics. All 3 entered the sub at 6:42 a.m. A short checklist was recorded by Hesperus crew, along with a time-stamped video showing the crew sealing the hatch, running basic pre-dive calibration, and initiating descent. The sub detached at 7:14. By 7:31, it was 210 meters down, and by 7:54, it had reached 1,870 meters, just above a trench shelf known locally as Chaldaic Drop. Initial telemetry was normal. Cameras on the exterior hull showed silt drifting past the viewport in slow motion. Internal sensors recorded faint biological activity, schools of cusk eels, a pair of slow-moving rays. Temperature hovered around 2.6 degrees Celsius. The crew seemed calm. At 8:09, Captain Harrow's voice was heard on the uplink. "We're approaching the shelf. Visibility good. Holding steady." And then, 5 minutes later, came a final transmission. Proceeding to grid point 12F. Estimated arrival at 8:23. No anomalies. After that, nothing. No distress signal, no system error. Just silence. The support crew on Hesperus assumed the comms had dropped temporarily. Not unusual at those depths. They logged the time, initiated backup telemetry, and waited for the next ping. None came. By 8:46, over 20 minutes overdue, The crew initiated standard retrieval protocol, a soft tether ping designed to trigger ascent in case of communication failure. Usually, this prompt activates the backup return sequence and begins surfacing. This time, something strange happened. At 8:47, Vortex 9 initiated an emergency ascent, but not via programmed protocol. Its propulsors activated manually. Its ballast tanks blew in reverse order, a method never used in simulation. Within 10 minutes, the sub breached the surface. The Hesperus crew located it 600 meters from its drop point. The sub was listing slightly, but otherwise intact. They towed it in, and when they opened the hatch, they found it empty. No sign of the crew, no damage to the hatch, no flooding, no tampering. Every personal item was still inside. Harrow's watch, Selwyn's bag, Sinhar's tablet. There was no evidence of breach, no life vests missing, no escape suits removed. But the strangest detail came from the internal diagnostics. The sub's control panel was completely offline. Manual overrides had been switched off, environmental controls disabled. Even emergency transponders, designed to auto-activate during crisis, were in standby. And the main camera, facing forward toward the viewport, its final frame was still cached. The 3 crew members sat in silence, unmoving, facing forward, eyes wide open, not speaking, not signaling, just staring. The timestamp on the frame was 8:17, 6 minutes after their last transmission. They appear alert, focused, no visible panic, no struggle, just locked in place, gazing toward the front window. The image ends there. The footage contains no flash of light, no sudden vibration, no intrusion, just that one still moment. And after that, nothing. No data, no motion, no recording of ascent. The next logs are blank. The retrieval sparked an immediate investigation. The Vortex 9 was hauled back to the facility in Edinburgh and subjected to a full diagnostic autopsy. No hull damage, no atmospheric breach, no internal toxic agents. Oxygen levels remained within normal range at the time of disappearance. The pressure seals had not failed. There was no sign of implosion, no sign of explosive decompression. The data ports had been wiped between 8:17 and 8:47, erased at root level. Experts believe it would have taken deliberate access. Yet there was no record of crew movement within the cabin. No footsteps, no handling logs, no finger smudges. It was as if they had simply vanished. Speculation spread quickly. One theory suggests the crew may have experienced sudden dissociation, a neurological event triggered by unknown environmental stimuli. This is supported by the fact that all 3 were staring forward, at something, when last recorded. But what could induce 3 trained individuals to freeze simultaneously and then never move again? Some believe the viewport itself holds a clue. Unlike traditional portholes, the Vortex 9's viewport was engineered to allow for maximum peripheral immersion, meant to reduce claustrophobia and encourage intuitive navigation. But this design may have created a new kind of vulnerability. If the crew saw something outside, something unexpected, the effect might have been overwhelming. But there's no visual record of it. The external camera continued recording until 8:16, showing nothing out of the ordinary. Just slow-moving particulate. No shapes, no shadows. Others have proposed a form of localized electromagnetic interference. This is based on a magnetic spike recorded in the surrounding water at 8:18, just 1 minute after the final crew image. The spike was brief, but sharp. Power levels within the sub dropped rapidly after this moment. Some believe the interference could have affected the crew neurologically, perhaps triggering hallucinations or paralysis. But once again, the evidence is limited. No known marine phenomenon can cause selective neural disruption without affecting surrounding electronics. And yet, that's what makes this so strange. The systems failed, the people vanished, but the machine came back, intact. Others, those more willing to tread the edge of plausibility, have offered different ideas. One suggestion comes from deep-sea mythos, the notion of liminal encounters, that is, encounters not with physical entities, but with spatial anomalies, places where orientation collapses, where time feels wrong, where direction and logic no longer hold. Could Vortex 9 have descended into one of these pockets? There is precedent, if only anecdotal. Divers in the 1970s reported momentary displacement off the coast of Norway, claiming to have seen impossible geometries on the seabed, only to return seconds later to find minutes had passed on the surface. Submariners have told stories of deep water silence, moments where all sound vanishes, including the hum of their own engines. Even older legends speak of mirrored water, places where ships appear to see their own reflection beneath them, glowing slightly, but skewed. Is it possible that the Vortex 9 encountered something like this? Something real, but undetectable by the usual tools? Or was it simpler and more tragic? A malfunction? A suicide pact? A planned escape? All of these were considered, and all discarded. There was no evidence of planned disappearance, no messages, no behavior changes, no opened hatch. And the sub's escape systems were untouched. No lifeboats, no hatches unsealed, no EVA suits disturbed. They did not leave the sub. And yet, they are gone. In the months following the incident, the Vortex program was halted indefinitely. The other prototypes were grounded, research suspended. A quiet report, labelled inconclusive, case pending, was filed with the Ministry of Marine Exploration. Families were notified. No remains were ever found. In 2023, a memorial was erected on the Isle of Lewis. 3 basalt stones, unmarked, arranged in a line facing west, toward the trench where Vortex 9 went silent. At night, when the sea is calm, the locals say you can hear a soft hum just offshore. Not mechanical, not musical, just steady, like something deep and far away is still moving. Some believe it's the current, others think it's the sea remembering. But for those who knew the crew, the question lingers. What did they see? What locked their gaze and kept them still? What force removed them from their vessel without damage or sign? Was it the ocean, or something in it, or something under it? And perhaps most haunting of all, did they leave, or were they taken? The Vortex 9 remains stored in a secure hangar. It has not been disassembled. Its systems have not been restarted. The Institute maintains a quiet watch. Once a year, the power is tested, just a pulse, to ensure the unit remains dormant. And once a year, its onboard clock ticks forward by exactly 1 second. No one knows why. Its power cells are drained, its circuits disconnected. Yet still, that single tick, a whisper of time, a hint of motion, as if something inside is still keeping time, still waiting, still watching, and perhaps one day ready to surface again, with answers, or with something else entirely. Story 12. The Descent of Echo 7. from a vessel that returns without its crew, to a whisper of time ticking forward inside an unpowered hull, to instruments that still function, but only just, as if watched, not abandoned. We now travel south, not far in distance, but much deeper in tone. This next mystery does not begin with disappearance. It begins with sound, but not the usual kind. Not the churn of ballast pumps or the distant call of whales. Not the static hum of sonar or the creaking of strained hull plates. This was something else. The year was 2011. The location, the Scotia Sea, a place swept by freezing currents and flanked by some of the most volatile tectonic intersections in the southern hemisphere. It was here that a research team deployed an experimental vehicle known as Echo 7. And what Echo 7 heard on its way down has never been explained. It wasn't the machine that made the noise. It wasn't inside the vessel. The tapping came from the water around it. Regular, rhythmic, louder the deeper it went. And just before communication was lost, a single, chilling message was transmitted back to the surface. Are we hearing this, or is it hearing us? Let's descend. The Scotia Sea is not an easy place to work. Located between the southern tip of South America and the icy sweep of Antarctica, the sea is boxed in by island arcs and the submerged ridges of the Scotia Plate, a twisted geological puzzle piece wedged between colliding tectonic giants. The weather here is brutal. Winds scream across the surface with little warning. Temperatures plunge without pattern. And beneath it all, beneath the waves and the ridgelines and the icy chop of the sea, lies a trench system barely understood, the South Sandwich Trench, one of the least explored subduction zones on Earth. And into this void, Echo 7 was sent. The submersible was part of a joint program, one that remains to this day largely unpublicized. A collaborative effort between two research institutions, one based in Argentina, the other quietly funded through a Northern European defense grant. Officially, Echo 7 was a test bed, an autonomous research platform designed to map acoustic topography under extreme pressure. Unofficially, it was built to listen. Outfitted with a circular array of wide-range hydrophones, a multi-spectrum sonar emitter, and layered external vibration sensors embedded in its shell, Echo 7's purpose was to record sound from all directions, both natural and otherwise. The descent began on the morning of June 3rd. Sea conditions were marginal but acceptable. Visibility poor, wind speeds rising, but no immediate risk of storm activity. A research vessel, the Terschelling, held position 17 kilometers east of the South Sandwich Islands. Echo 7 was lowered into the water at 0724 UTC. Its mission, to descend along the inner slope of the trench wall, record ambient acoustic data at 4 pre-designated depth intervals, and surface no later than 1800 hours. By all accounts, the descent proceeded as expected. For the first hour, telemetry remained steady. Pressure readings, orientation, navigation corrections, all routine. At 0906 UTC, Echo 7 reached its first checkpoint, 1,000 meters below sea level. That's when the first sound was detected. At first, it was dismissed. A soft, hollow clicking, intermittent and irregular. Surface crew assumed minor ice carving from nearby submerged shelf edges. But by 1,500 meters, the pattern had changed. The clicking was no longer intermittent. It had become tapping. 2 taps, pause, 3 taps, longer pause, repeat, then again, then louder. The hydrophone logs would later reveal that these taps weren't random, not just in rhythm, but in spatial origin. They didn't come from one source. They circled the sub, always equidistant, always just beyond the sonar's outer range, as if mimicking orbit. By 2,400 meters, the taps were accompanied by a low-frequency resonance, a sound not unlike a bowed metal plate or the reverberation of a struck cable, drawn out, faint but present. Surface crew began running diagnostics. Could the hull be warping under pressure? Could internal tension in the sub's metal frame be releasing kinetic noise? But stress data from Echo 7's onboard strain gauges showed no anomalies. In fact, the hull was unusually quiet. Too quiet. Normally, a submersible descending into such depths creaks and groans in response to pressure. Echo 7 was silent, dead silent, as if the water around it was absorbing the strain. At 2,800 meters, the taps grew louder again. Not in volume, in proximity. One by one, the hydrophones registered contact. First on port, then starboard, then after. Not impacts, not collisions, just pressure shifts, as if something outside the hull was pulsing. Not hitting, not scraping, just existing, moving. And then, at 2,975 meters, Echo 7 sent its final transmission. The log contains no technical readout, no error codes, no failures. Just a short message, sent manually, as text. Are we hearing this, or is it hearing us? Then, silence. All signals ceased. Telemetry, sonar, internal logs, gone. Surface crew initiated immediate recovery. Echo 7 was outfitted with a dual buoyancy release system, capable of triggering automatic ascent in the event of system failure. But it never rose. Emergency pings were broadcast to trigger the sub's passive homing response. No reply. They waited. 6 hours, then 12, then 36. No trace. On June 7th, an autonomous search drone was deployed to scan the trench wall. On the second day of grid sweeps, the drone located a debris field. But not on the seafloor, not even at maximum depth. The debris, or what little of it there was suspended. Scattered fragments of alloy plating, bits of sensor housing, and a single twisted support ring were found lodged along a vertical shelf face. Halfway down an abyssal chimney. A chimney that had not been charted before. A vent of unknown depth, carved into the trench wall like a wound. Echo 7 was gone. No implosion field, no hull fragments, just remnants, and all of them deformed, not by pressure collapse, but by extreme torsion, as if the sub had been bent, pulled. The fragments were recovered and sent for analysis. But no trace of explosive damage, no signs of compression rupture, no trace of combustion. Just stress lines, elongated, irregular. And here's where the mystery deepens. Several of the recovered components bore internal etching, not from manufacturing, not from corrosion, but from abrasion. Fine lines, parallel grooves, all evenly spaced, as if something had run over them, again and again and again. Not with violence, with persistence, with attention. When presented with the findings, the Research Institute quietly discontinued the ECHO project. No replacements were commissioned. The test program was classified retroactively, and all involved personnel signed extended NDAs. But one transcript remained, recovered by a technician who had copied the final logs onto a personal drive before the data was sealed. It contains the last 3 minutes of Echo 7's acoustic recording. Much of it is silence. But at timestamp 2:57:14, the tapping resumes. 5 taps. Long pause. 5 more. then a low, sweeping hum, rising in frequency. The final sound on the file is ambiguous. Some say it resembles the winding of a spool. Others compare it to the sound of breath, amplified, distorted by pressure. Then the line cuts out. What could it have been? Oceanographers have offered a few theories. Some suggest volcanic tremor, low-frequency resonance caused by magma movement beneath the trench wall. But tremor data from the region that week showed no seismic activity, no tremors, no quakes. Others propose acoustic reflections, an illusion created by sound bouncing inside complex trench geometry. But the taps weren't echoes. They weren't repeating previous noises. They were unique. They formed patterns. Several marine biologists have cautiously proposed the possibility of deep-sea bioacoustics, the calls of a large, unknown organism, an echolocating species using sonar-like pulses to navigate. But if so, it would have to be colossal, larger than any known animal in the region, and capable of maintaining consistent distance from a descending object. That behavior alone is unprecedented, because what the hydrophones show isn't just sound, it's movement, positioning, a kind of orbit, not around the sub, but with it, shadowing it. Then there's the more esoteric speculation. Some suggest a resonance field, a natural phenomenon caused by extreme magnetic or gravitational anomalies in the trench wall, that the taps were artifacts, pressure fluctuations caused by interaction between the sub's systems and unknown geological factors. But again, nothing in the sensor logs supports this. There was no EM interference, no power surge, no magnetic disruption, just sound. And then, absence. A few voices, unofficial, fringe researchers, have offered something else. They point to the rhythm, the increase in volume with depth, the spatial coordination of the taps. They suggest something intelligent, something that responds, watches, something that didn't interfere, until it did. Because here is the most chilling part. Echo 7 was designed to transmit acoustic pulses at specific intervals, part of its sonar mapping suite. These pulses weren't loud, but they were regular. One pulse every 90 seconds. But shortly before the final message, the pulses changed. Not by the submarine, by the taps. They began to mirror the sonar rhythm. First a match, then a delay, then a match again, as if adjusting, synchronizing. One technician described it as a duet, one voice leading, the other learning. Another theory, equally haunting, that the sonar pulse wasn't a broadcast, it was a knock, and something knocked back. What could do that? Some speculate advanced systems, not biological at all, but mechanical, devices left behind, or still active, remnants of a Cold War project, or something older, structures built to listen or warn. There are legends, whispered in maritime lore, of regions where sound behaves strangely, where radios go silent, where steel vibrates without cause, where ships drift off course without reason. The Scotia Sea, with its volcanic ridges and thermal vents, has long been considered one of those places. But until Echo 7, no one had proof. Now, there is data, partial, fragmented, unconfirmed, but still something. The final message remains a question, a whisper from the deep. Are we hearing this, or is it hearing us? We still don't know the answer. The debris sits locked in a facility outside Ushuaia, its stress fractures still unreadable, its grooves untouched, its mystery intact. No further missions have been approved, and the site of Echo 7's disappearance, the narrow trench along the South Sandwich Slope, remains uncharted, marked only by a note in the logs, unstable descent vector. Recommend future avoidance. But some say avoidance is not enough, because something there is listening. Whether it was always listening or only just awakened, no one can say. And perhaps it doesn't matter, because the sound is still there. Hydrophones still pick up tapping in the region, faint, sporadic, but always at depth. Some nights, the rhythm returns. 5 taps, pause, 5 more, then silence, as if waiting. And those who listen closely say, if you echo it, it echoes back, but not immediately. Not in haste, in patience, as if it has time, as if it always has. Waiting, beneath pressure, beyond sight, listening, and now aware that we are listening too. Story 13. The submarine boneyard of the Labrador Shelf. And perhaps not all echoes are heard in the moment they are made. Some travel across darkness, across time, bouncing through the silence of the deep before finally returning, changed, warped, a message reshaped by distance and pressure. But not all messages return. Some sink, some settle into the folds of the seabed, and some are waiting to be found. Not far from the underwater plains of the Scotia Sea, where Echo 7 heard what it could not explain, the continental shelf of eastern Canada begins to arc north, broadening into a vast, glacial-scored slope known as the Labrador Shelf. Cold, expansive, and largely uninhabited, this stretch of the North Atlantic is a world of silence. Beneath the shallow currents that sweep past Newfoundland and curve toward the Arctic Circle, the sea floor drops suddenly into deeper channels, where sediments pile like snowdrifts, and the past is preserved in layers of quiet stone. Here, beneath the grey waters and drifting ice, lies a mystery that no one meant to find. It began in 2016. A survey vessel, part of a routine geological expedition, was tasked with mapping the sediment layers of the outer Labrador Shelf. The mission was straightforward: acoustic profiling to assess undersea slopes, identify areas prone to submarine landslides, and help guide future drilling routes. The equipment was standard: a multi-beam sonar array towed several hundred meters below the surface, scanning the depths like a flashlight across a cave wall. What it returned wasn't standard at all. On the live monitor, the seafloor appeared mostly flat. Soft ridges, some scarring from ancient glaciers, and long stretches of unremarkable silt. Then, something blinked. A faint outline, cylindrical, repeating. The sonar passed over it again. This time, the shape sharpened, a long, symmetrical form, half buried in sediment. Just ahead of it, another. And then, dozens, all aligned roughly parallel, spaced unevenly, but in a narrow cluster, like bones in a shallow grave, or pods arranged for deployment. They were not geological. They were not part of any recorded wreck, and none of them matched known designs. At first, the survey team assumed they'd come across an old naval debris field. Perhaps World War II wreckage or Cold War dumping, submarines scuttled, torpedoes abandoned. But the records didn't match. No fleet had been lost here. No submarines had ever been listed as missing in this section of the Labrador Shelf. The dimensions were inconsistent. Some were just under 40 feet, others nearly double that. None had markings. None had propulsion fins, hatches, or visible compartments. But all of them were tube-like, hollow mostly, and too deep to inspect without specialized equipment. The discovery was quietly flagged. Data was sent to marine archaeologists and naval historians, but answers came slowly, and none with confidence, because the more the scans were reviewed, the stranger the pattern became. Most shipwrecks scatter. Debris spreads outward, torn by impact and current. But this field had order. It wasn't perfect. Time had worn it down. Some objects were tilted, half submerged in silt, others partially buried or broken at one end. But the orientation was broadly consistent, almost like they had landed here deliberately or been placed. The nickname arrived by accident, one whispered by a junior analyst during a late-night review session. The Submarine boneyard, and once said, it stuck, because that's what it looked like. Dozens of long, silent carcasses lying in parallel beneath a cold, grey sea. No names, no nations, no story. Just there, waiting. A deeper scan in late 2017 confirmed that at least 34 distinct structures lay within the cluster, extending over a 2.5-kilometre stretch of seafloor. The sediment profile suggested they had been there a long time. But how long? Dating objects buried at this depth isn't easy. The Labrador shelf is geologically active. Currents shift, sediment layers accumulate unevenly. But rough estimates placed the shallowest layers over the wrecks at several decades old, possibly more than a century, which meant they'd been down there a long time, long enough for records to have existed if they were man-made. But nothing came up. No declassified logs, no Soviet reports, no American losses, no Canadian training exercises gone awry. And the size was all wrong. The dimensions of the objects did not match those of typical submarines, military or otherwise. Too small for crewed missions, too large for torpedoes, too featureless for storage tanks, and too aligned to be trash. In 2018, a classified joint exploration team was assembled, involving maritime historians, naval engineers, and oceanographers from Canada and Europe. They launched a small fleet of ROVs, remotely operated vehicles, to dive and inspect the site firsthand. But visibility was poor. The Labrador shelf is cold, its waters murky with silt and particulate matter stirred by the continental slope. The ROVs descended slowly, headlights cutting through darkness like candles in fog. And then, one by one, they found them. The first object loomed from the haze like a shadow rising from the sand, a long, cylindrical shape, crusted in layers of marine growth. Manganese nodules, deep-sea barnacles, but no numbers, no rivets, no weld lines, no windows, just a faint seam running its length like a mouth long shut. The ROV's robotic arm extended, brushing away sediment near the surface. Underneath, the surface was smooth, almost unnaturally smooth, not corroded, not torn, but whole, as if it had never been breached at all. The sonar images had suggested possible hull damage, but up close, most of the objects were intact, just buried, dormant, unmoving. Further scans detected no radiation, no electromagnetic signals, no energy output of any kind. The interior, as best as could be determined through limited acoustic resonance, was hollow in some, partially filled in others. But none were pressurized. None were active. They were not reactors, not torpedoes, not escape pods, and not listed in any catalogue of naval craft, past or present. The materials posed another puzzle. Samples taken from surface corrosion revealed an alloy unlike standard submarine steel. Not exotic, not alien, but inconsistent with known manufacturing techniques from any era. Titanium traces, low-carbon manganese structures, high uniformity, no paint, no ballast control features, but highly resistant to corrosion. In 2020, after 3 years of quiet debate, the team came to an unsettling consensus. Whatever these were, they had not been deployed by any nation currently willing to claim them, and they had been resting here, undisturbed, for decades, possibly longer. So the theories began. Some proposed these were the remnants of a failed undersea experiment, perhaps Canadian, perhaps American, an attempt at deploying seafloor sensors or remote drones that never fully came online. But there were problems with this. If it were a Cold War experiment, why the variety in size? Why the uniform orientation? Why the complete lack of cabling, anchoring systems, or external modules? And why had no one come to recover them? Others speculated they were part of a secret Soviet operation, an unmanned weapons test, or a long-range minefield deployment designed to disrupt NATO's submarine patrols during the height of East-West tensions. Again, problems. Soviet naval deployments in the North Atlantic were heavily tracked by NATO in the 1970s and 80s. No evidence, classified or declassified, ever mentioned a mission like this, and the objects did not resemble Soviet-era underwater weapons. They lacked fuses, they lacked propulsion systems, and they lacked decay, the kind that occurs when explosives are left to corrode in seawater for decades. So the question remained, what were they? A more fringe theory began to circulate among oceanographic circles, one that suggested these structures might not be vessels at all, but husks, shells, biological in shape, mechanical in composition, perhaps something in between. One marine biologist reviewing the ROV footage noted the repeated absence of attachment points, screws, or plates, hallmarks of human engineering. Instead, the objects seemed grown, formed as a whole, like exoskeletons or cocoons. A few dared to wonder, were these not vehicles, but something else entirely? Fossils? Encasements? The scale didn't fit any known species, not even prehistoric ones. But deep-sea biology is full of unknowns. Gigantism is common at depth, as seen in the immense isopods and squid found far below the photic zone. Could these have been organic once? If so, what grew them? What emerged from them? And where did it go? Skeptics pushed back. The shapes were too uniform, the spacing too deliberate. But the absence of any propulsion, hatchways, or fuel residue still puzzled them. In the fall of 2021, a new scan was conducted, this time using synthetic aperture sonar, capable of capturing high-resolution subsurface imagery. It revealed something new. Beneath the top layer of sediment, some of the objects appeared to extend deeper than expected, like roots tapering downward. Not just resting, but embedded. And in a few, fine lateral striations were visible, markings along the inner edge of the cylinder walls suggesting they had once spun, or vibrated, or opened. But when? And for what? No signs of recent disturbance were found. No heat signatures, no chemical anomalies, just cold, stillness, time. The sea, as always, had kept its secrets well. By 2022, the site was cordoned off from commercial exploration. Not publicly, not officially, but quietly. Future expeditions were delayed. Permits stalled. Satellite coverage in the area became limited. And the boneyard faded from public mention. But the scans remain. And those who have seen them still talk. In quiet rooms, in academic halls, in private circles. Because nothing about the site makes sense, and the sea is not in the habit of laying things out so deliberately. So what are we to make of it? Dozens of hollow cylinders buried in sediment, lined in quiet procession beneath the Labrador shelf. No markings, no nation, no purpose. Too shallow to be natural, too deep to date precisely, and too symmetrical to dismiss. Some whisper of forgotten war games, abandoned technology, a design lost to time. Others suggest darker things, that these are the remnants of something older, not man-made, not recent, perhaps not even meant to be found, that they are relics of another purpose, another presence, a message, perhaps, or a warning, a reminder that the sea has layers we have not yet peeled back, and in those layers lie shapes we do not understand, and patterns we are only beginning to see. Because the boneyard is not just a graveyard, it is a map, a formation, a code written in iron and silence, and like Echo 7 before it, we are only just learning to listen. The question is, what happens when it listens back? When the silence becomes signal, and the shapes beneath the sea begin to stir. But for now, they rest, as they always have, still, unclaimed, waiting beneath the Labrador shelf, waiting for time. Story 14. The Project Borehole Zulu. Not all signals from the deep are broadcast to the world. Some are intercepted, silenced, and quietly buried beneath layers of classified ink. Because for every sound we study, every ghost ship we recover, there are others we are never meant to hear about. Missions that vanish from public record. Expeditions that disappear before they're ever acknowledged. Teams that go down and are never listed as missing. And while the Challenger Deep has become a symbol of known extremes, there are other regions in the Pacific that exist in that strange half-space between exploration and erasure. Places like the Tonga Arc, a volcanic spine of underwater ridges and subduction zones that stretches north of New Zealand like a wound in the seafloor. It is here, amid unstable hydrothermal vents and tremor-prone chasms, that a whisper of something else emerges. Not a sound, this time, but a name. Project Borehole Zulu. A phrase that appears only briefly in the margin of a leaked memo from the late 1990s. Redacted heavily, marked with obsolete clearance codes, and buried in a forgotten server directory. The document surfaced online only once, before being taken down within hours. No official agency ever claimed authorship. No one ever confirmed the mission. And yet, it tells a story of a dive that was never logged, of a vessel that never returned, and of something that should never have been found. The document was recovered in 2003, uploaded anonymously to a private maritime research forum under a username that posted only once. It contained a fragmented briefing, a scanned page, misaligned and yellowed, with the header partially burned out by what looked like photocopier streaking. The only clearly legible text? Zulu class operation. Unmanned observation suspended. Asset deployed, manned. Entry, November 1997. Tonga Arc Fault Cluster, grid reference. Redacted. Vent sequence registered abnormally high thermophilic emission. Unknown structure observed. Descent permitted. Last ping, 134 meters. No official seal, no agency stamp. Just one line in handwriting, bottom right corner. Do not attempt retrieval. No further dives approved. And then, nothing. No follow-up logs, no incident reports, no names. Only a call sign, Borehole Zulu. It would have disappeared entirely, dismissed as another online hoax, if not for one peculiar detail. In January 1998, satellite data from a civilian oceanographic institute picked up a faint heat anomaly in the Tonga Arc region. A plume rising from the seafloor for just 6 hours. By the time the next pass occurred, the plume was gone. But the sea temperature above the grid remained elevated for days, even though no volcanic event had been registered. And in the archived metadata of that brief pulse was a signal, compressed, fragmented, but structured. A series of sonar pulses, 5 in total, increasing in frequency, then vanishing mid-transmission. They've never been replicated, and the region has never been scanned again. But what is the Tonga Arc? And why would anyone risk a manned descent into such unstable terrain? The Tonga Arc lies in the western Pacific Ocean, a tectonic boundary that ranks among the most seismically active places on Earth. Stretching from the Kermadec Islands in the south to Samoa in the north, the arc marks the subduction of the Pacific Plate beneath the Indo-Australian Plate. It's a violent place, an undersea trench and volcanic chain where Earth's crust bends, buckles, and releases immense energy. At its core, it's a factory of deep-sea vents, superheated fissures in the ocean floor that spew mineral-rich fluids into the abyss. These vents can reach temperatures of over 700 degrees Fahrenheit, yet around them, life thrives in alien forms: tube worms, chemosynthetic bacteria, crustaceans with translucent shells and glowing eyes. To study this ecosystem is to glimpse a world unlike any on the surface. But it's not just life that lures scientists here. It's the vents themselves, the heat signatures, the anomalies, the rare Earth elements carried from the Earth's mantle, and sometimes the unexpected. In October 1997, just a month before the classified descent, a group of marine geophysicists aboard a Taiwanese research vessel reported unusual activity near the northern Tonga Trench. Their instruments picked up a sharp deviation in baseline thermal output, as if something beneath the seabed had shifted. They reported the finding to regional agencies. The data was shared, reviewed, then quietly removed from public access within a week. No explanation was given. Soon after, Project Borehole Zulu appeared. What little we know of it has been reconstructed not from any official account, but from whispers in archived engineering forums, declassified vessel logs, and one interview, never aired, recorded by a German documentary crew in 2006. The interviewee was a retired sonar technician named Hans Dieter, who had worked on contract for an unnamed maritime research division in the late 90s. When asked about strange expeditions, he described an incident off the Tonga Arc. One, he said, was scrubbed before it even started. He claimed a deep-sea submersible was deployed. Military-grade, experimental hull, not standard Navy issue, to investigate what had been described to him as a geothermal breach. According to Dieter, the mission was brief: 2 hours of descent, a sonar ping every minute. And then, nothing. No explosion, no pressure spike, no implosion signature, just silence. The craft never returned. Its beacon never resurfaced. And when a second vessel was sent 3 days later to investigate, it was rerouted mid-transit and told to stand down. I asked what happened, Dieter recalled in the interview, and they said, "We saw enough. That's all they told me. We saw enough." The footage was never aired. The documentary was shelved, and Hans Dieter passed away 6 months later. The dive site was never revisited. But those 5 sonar pulses, logged by civilian satellite instrumentation just hours after the last known contact, remain. Researchers who analysed them noted that the pulses formed an unusual crescendo. a sequence that increased in amplitude and frequency before cutting off mid-pattern. Some have compared the structure to known biological signals, echolocation bursts, for instance, used by sperm whales or deep-diving dolphins. But the frequency was wrong, too low, too deliberate. Others have suggested the signal resembled early Cold War sonar tests, a kind of passive ranging technique used in the 1960s where pulses were sent out in specific harmonic intervals to detect terrain curvature beneath the sea. Except, no such equipment was listed on any vessel in the region, and no known research submersible, especially one from the 1990s, would have been capable of transmitting that frequency pattern, let alone autonomously. That's where the theories begin, the ones that push beyond geology, beyond biology, into the realm of the unknown. Some believe the vent was not natural, that the anomaly recorded by satellite was not a volcanic plume, but a release, a sudden opening of something long buried. A fissure, perhaps, or a chamber, one that had been sealed until tectonic shifts forced it open. And inside? That's where speculation turns strange. A 2009 fringe science journal, published under pseudonyms and quickly disavowed by its alleged contributors, claimed that the Tonga Arc is home to geometrically consistent formations at depths of over 6,000 meters. The authors referenced magnetic anomalies, repeating sonar echoes, and what they described as non-random rectilinear scatter, patterns too uniform to be natural. They included illustrations, hand-drawn schematics of what looked like vents arranged in a spiral, their centers marked by nodes. According to their model, Borehole Zulu descended into one of those nodes and triggered something. Other accounts are less structured, more myth than science. A story passed around the docks in Suva, Fiji, tells of a ship whose crew went silent after encountering a black bloom in the water, an ink-like cloud that rose from the depths and lingered in place despite the currents. The ship, a local freighter, rerouted immediately. The crew refused to speak of what they saw. They docked a day later with their instruments dead, and their external paint scorched near the waterline. That story was told in 1998, the same year the Borehole Zulu transmission ended. And there is one final detail, buried in a procurement request from 1996, declassified only by accident. It referenced a manned submersible designed for extreme thermal proximity and brief hover deployment. It was manufactured in part by a defense contractor in San Diego, one known for its work on stealth materials and sonar dampening technology. The internal name for the submersible, Zulu-1. Its range was limited. Its shielding was rated for volcanic vent exposure. And its pilot capsule, according to the request, included a non-standard sensory recording module, infrasound, a system used to detect ultra-low frequency vibrations typically employed in atmospheric monitoring or animal communication. Why would such a system be installed on a one-person dive craft? Unless they weren't just expecting to observe heat. Unless they were listening. But for what? What lives in a vent so hot that it should sterilize all life? What calls back through a plume that only rises once and never again? What did they hear? Theories range from deep Earth seismic phenomena to unknown biological resonance. The idea that some life forms communicate in frequencies so low, they pass through rock like radio through air. Others believe the pulses were not messages, but warnings, echoes from something we disturbed, a dormant system, a pressure valve, or something far older. Some point to the 134 meters noted in the leaked document, the last known ping depth before all contact was lost. Not 134 meters from the surface, but 134 meters from something else. The vent shelf, a chamber ceiling, or a structure, one with walls. In 2015, a private ocean drone surveying the southern Tonga Ridge abruptly lost propulsion after entering a narrow trench. Its onboard footage, corrupted and fragmented, captured only 8 seconds of visual data before freezing. Those seconds show the seafloor. Dark basalt, vents in the distance, and then something in the foreground, a line, too straight, too long, cutting across the frame like a rib. No geological features in the area are known to run in that direction. The footage has not been released, but a single still, leaked later that year, appears in the final slide of a presentation titled Thermocline Disruptions in Pacific Arc Subduction Zones. It shows only a portion of the seafloor, but beneath the silt, the faint outline of an angle, not curved, not eroded, a right angle. Nature rarely builds with corners, and yet there it is, half buried, silent, waiting. So what was Project Borehole Zulu? A mission to study geothermal emissions? A covert deployment? A test? Or a mistake? The submersible was never recovered. No bodies, no debris, no pressure signature, only a heat pulse, a signal, and silence. No mission logs, no crew manifest, no recovery attempt. Just a note: do not attempt retrieval. No further dives approved. And a name: Borehole Zulu. A name not found in any oceanographic record. A name that shouldn't exist. And yet, here it is, whispered in fragments, drifting through forums, shadowed in classified files, etched in the memory of a sonar tech who saw the data once, and never again. The ocean holds many mysteries. Some rise to the surface, others are pulled back under, and some are never meant to be found at all. What lies beneath the Tonga Arc? What pulsed through the vent on that quiet November day in 1997? And why, after decades of ocean exploration, do we still not return? Is it the danger, the heat, or something else? Something watching? Whatever happened during Project Borehole Zulu, one truth remains. The signal stopped, and no one ever went back. Story 15. The Janus Report. Not all messages from the deep are so easily captured. Some come not in waves, but in whispers. Whispers buried in servers, buried in data packets, buried beneath denials. Because not everything beneath the ocean was meant to be heard. The following mystery does not begin with a wreck. It does not begin with a sonar ping, or the groan of shifting tectonic plates, or even the call of a creature yet unnamed. It begins with a file, encrypted, fragmented, unlabeled. A file that made its way into the inbox of a retired oceanographic engineer in Annapolis, Maryland. No explanation, no sender, no source metadata. Just a single word in the subject line: Janus. The attachment contained a compressed directory. Inside, over 400 pages of declassified-looking logs, date-stamped transmissions, engineering diagrams, personnel rosters, coordinates. Most were redacted beyond usefulness. Some were indecipherable, but a few, just a few, were readable, and they hinted at something remarkable, something secret. A program allegedly run by the United States Navy somewhere between 1997 and 2008, involving a fleet of submarines retrofitted not for warfare, but for listening. The documents referred to them not by name, but by initials: SSN 837J, SSN 854J. The J believed to denote Janus retrofits, each one equipped with a new high-fidelity seafloor monitoring package, hydroacoustic arrays, low-frequency electromagnetic sniffers, and, most curiously, a device labelled simply as biologic attractant mesh. Their mission? To remain hidden, parked in seafloor folds near trench walls and fracture zones. Silent, passive, listening. For what? The files do not say. But in some of the logs, there are patterns, strange ones. Signal captures with notes attached by unnamed technicians. Lines like, persistent rhythmic motion below sediment layer, non-seismic, or chorus signature non-cetacean, 88 Hz, 92 Hz, responsive to magnetic pulse. And this, movement pattern does not match any known current. Object appears to circle trench perimeter once every 14.5 days. No identifiable propulsion. These snippets, if real, point to something extraordinary. Not just sounds, but behaviors. The ocean, as vast as it is, rarely shows repetition. And yet here were reports of recurring paths, timed circuits, frequencies that echoed in sequence. To the outside world, these were just anomalies, if they existed at all. But to the handful of people who saw the Janus files, they felt like footprints. And perhaps they were. The name Janus itself is curious. In Roman mythology, Janus was the god of gates and transitions, of doorways. He was depicted with two faces, looking both forward and back. Why that name for a seafloor surveillance program? Unless it was meant to imply something being watched at the threshold, something at the edge of the known world and the unknown. A doorway in the deep. The coordinates embedded in the Janus logs are scattered. Some point to known trenches: the Kuril-Kamchatka, the Kermadec, the Puerto Rico. Others are more obscure, including several pings along the Diamantina fracture zone, a remote stretch of ocean off Western Australia. One set of coordinates appeared over a dozen times in different documents: 19 degrees 35 minutes south, 174 degrees 20 minutes west. That places it just west of the Tonga Trench, not far from the site of the ill-fated Project Borehole Zulu. According to the log entries, the submarine stationed there, SSN 854J, reported anomalous pulsing resonance over a 38-day period in late 2001. The pulses grew stronger as time went on. Then, abruptly, they stopped. 5 days later, the sub reported a short-duration magnetic spike, followed by what one note calls localized seafloor elevation change unlinked to tectonic shift, which means the ground moved, but the plates did not. Shortly afterward, the submarine was extracted. Its equipment was removed and rerouted to a research station in Guam. No further logs appear from that unit. In another document, buried under layers of redactions, there's mention of an incident during Janus Phase 3. The line is brief, almost like an afterthought. Request classified transcript. Incident Echo 4. Crew reported external knocking while submerged, vessel powered down. Multiple sources. Confirmed non-contact. External knocking. In the deep ocean, with all engines silent. The sound of something tapping on the hull. Not collision, not pressure fluctuation, not biological strike. Knocking, as if something was outside, waiting to be let in. None of the files explain what was causing these anomalies. There is no mention of whales or ships or known marine activity. But more than once, the same phrase appears in technician shorthand, EMR, electromagnetic resonance. In normal conditions, EMR signatures are faint. Seawater dampens them. Most marine life has no significant emission. Submarines, of course, are designed to minimize theirs. But according to these logs, the sensors were detecting elevated EMR emissions from below the sediment layer. Not above the seafloor, not drifting down, beneath it. Deep enough that the signal was muted, but not invisible. One log even estimates the size of the emission source. Initial field spread suggests profile no smaller than 240 meters linear length. That would make it longer than a nuclear submarine. And yet, there is no mention of movement, no mention of machinery, no propulsion trail, just a long, slow pulse, rising, then fading, and repeating, as if something deep beneath the seafloor was breathing. The engineer who received the Janus file said nothing for months. Then, quietly, they began forwarding pieces of the data to colleagues, always anonymously, always carefully. One of those colleagues, a retired NOAA acoustician, claimed to have recognized a pattern, not in the emissions themselves, but in the response. According to his notes, when one of the subs released a magnetic test pulse, a common calibration practice, the signal capture changed. The ambient tone that followed was lower, denser, as if the surrounding water had thickened or something within it had stirred. It was, he said, like tapping a glass aquarium and seeing the shadows shift. A few months later, he stopped responding to emails. The Janus files are not verified. No government agency has acknowledged the project. But piecing together the fragments reveals a timeline and a chilling possibility. The project seems to have been terminated abruptly around 2008. Not decommissioned, not phased out, terminated. Several final entries reference the removal of seafloor gear and the reassignment of crew. Some use the phrase, containment satisfied. One document, possibly incomplete, contains a hand-scrawled margin note. Do not re-establish contact. Let it go dark. It raises the most unsettling question of all. What were they listening to? And what listened back? The Janus program, if it existed, may have been one of the most ambitious underwater surveillance efforts ever undertaken. But unlike traditional submarine operations, which focus on nations, ships, and military movement, Janus was aimed downward, not toward threats above, but mysteries below. It treated the seafloor not as terrain, but as interface, an interface that pulsed, that responded, that perhaps held something more, something we weren't meant to find. One set of logs details wake displacement not linked to prop wash. Another references non-localized bioluminescent response in absence of known trigger. One entry, dated March 2004, simply says, sensed, nothing more. Who or what was being sensed? There are theories. Some believe the Janus program wasn't looking for objects at all, but for patterns, changes in water resonance, acoustic symmetry, the ocean's equivalent of facial recognition, not for faces, but for frequency. And when those frequencies shifted, something was awakened. A Navy contractor interviewed off record claimed that Janus was part of a broader defense research protocol focused on undersea behavioral modeling. He wouldn't elaborate, except to say that the behavior in question wasn't ours. In one of the surviving memos, a line appears near the end. It reads, recommend termination of stationary nodes. Passive net is insufficient. Containment architecture outdated. Possible escalation if perimeter patterns persist. Perimeter patterns. Containment architecture. Words that don't belong in ordinary oceanography. There's no follow-up memo. No resolution. just silence. The Janus files remain unconfirmed. The Navy has issued no statement. Most attempts to trace the origin of the leak end in dead ends. IP addresses bouncing through defunct nodes, hosting servers rerouted through overseas domains. But those who've seen the files, remember them. Because once you've read a page that ends with the phrase, "Trench perimeter migration continues," you don't forget. Especially when the timestamps show that migration increasing in frequency. Especially when the movement is circular. Especially when it stops at the same coordinate every time. A place labeled only as Gate 4. We don't know what Gate 4 is, or where it leads, or whether it was opened or closed. But we do know this. If the Janus program was real, it was listening to something. Something that pulsed, that echoed, that moved beneath the seafloor in patterns no current could explain. And whatever it was waking up. Not with a roar, not with violence, but with rhythm, slow, deliberate, geometric. And it was being recorded. By submarines no one acknowledged. On missions, no one briefed. Near trench walls, no one explored. What did Janus hear? What did it see? And why? Was it shut down? Perhaps it was simply a data collection program, a footnote in the long, quiet war for undersea supremacy. Perhaps it was nothing more than a network of instruments that reported anomalies and were dismissed. Or perhaps it found something beneath, something that circled and waited. A perimeter that was never meant to be breached, a gate that was never meant to be found, and a name, Janus, chosen not for what it watched, but for what it watched back. For now, the ocean keeps its silence. The seafloor sensors are gone, the logs erased, the echoes quiet once more. But silence in the deep is never empty. It is always listening. Story 16. The Leviathan Protocol. From the drowned whispers of Janus, a name once tethered to seafloor sensors and silent anomalies, we now drift toward another enigma. Not merely detected, but encountered. If the Janus report warned of something watching from below, then what came next may have been the moment it stirred. It's the story of a military exercise gone dark, of instruments destroyed, records scrubbed, and lives quietly reassigned. A NATO operation near the Mid-Atlantic Ridge. A US submarine recording something it could not identify, only describe. A moving mass, vertical, larger than the vessel itself. Official logs were erased, the incident buried, but some fragments remain. Let's descend into the mystery of the Leviathan Protocol. The Mid-Atlantic Ridge is a place of quiet upheaval, a deep-sea scar stretching over 10,000 miles across the floor of the Atlantic Ocean. Here, the Earth is still coming apart. Tectonic plates drift slowly in opposite directions, pulled by forces we barely comprehend. Volcanic ridges rise from the depths, creating new seafloor in a process as ancient as the planet itself. But in 1998, this geological theatre became the backdrop for something far stranger. That summer, under the code name Leviathan Protocol, NATO launched a coordinated naval exercise in international waters west of the Azores. On the surface, the goal was to test multi-nation submarine interoperability, communication redundancy, and recovery drills in deep water. But within certain classified corridors, the mission had another layer. The protocol was centered on a corridor between latitudes 36 and 39 degrees north, a region intersecting the deepest axial valleys of the ridge. These valleys, up to 2 miles deep, remain some of the least mapped portions of the Atlantic. Sonar behaves strangely here. Magnetometers yield inconsistent readings, and signals, acoustic or otherwise, have been known to vanish. For most of the summer, things proceeded as expected. Submarines from the US, UK, and France took turns running silent maneuvers, deploying signal buoys, and practicing emergency ascent drills. But on the night of August 23rd, something changed. A US Navy fast attack submarine, the USS Kavala, was operating alone near a trench called the Cane Fracture Zone, a submerged rift where the ridge twists unnaturally eastward. The Kavala had just finished its final dive for the day, a routine descent to test hull response and sensor calibration at depth. By all accounts, the sea was calm. Communications were stable. The ship's nuclear reactor ran flawlessly. Then, the sonar station went quiet. Not silent, not inoperative, but quiet in a way the crew found unnatural. The usual symphony of undersea life, the clicks of distant sperm whales, the groans of moving water, the static crackle of the sea, had vanished. In its place, nothing. Just a low, undulating hum, as if the entire ocean were holding its breath. The sonar technician on duty, a junior petty officer named Whitaker, would later tell a superior, "It was like someone had placed a dome over the boat, like the water changed." At 2:37 hours, that hum changed. Suddenly, a new contact registered. It wasn't a vessel, it wasn't a signal, it was a shape, vertical in orientation, at least 150 meters in height, possibly larger. Too slow to be a whale, too quiet to be a ship, and most disturbing of all, it was moving. Not horizontally, as ships and animals do, but vertically, rising. The Kavala's crew, trained to remain calm even in the most disorienting scenarios, began cross-checking every sensor array on board. They recalibrated sonar, restarted passive acoustics, even deployed a secondary buoy. All showed the same thing: a column of mass rising from below, with no cavitation, no echo signature, and no known propulsion. By 2:41, the contact passed beneath the Kavala. According to the logs, later classified, the vessel experienced a mild pressure shift, enough to jostle some equipment, but not severe enough to cause hull stress. Internal lighting flickered, and in the control room, several of the monitors registered brief magnetic anomalies, spikes in flux density inconsistent with local geology. The object, if that's what it was, continued ascending, but what happened next never made it into any official report. That information came only from leaks, from what former crew members whispered years later. They claimed the object didn't stop at the Kavala. It kept rising, all the way to the thermocline, the layer where cold deep water meets the warmer upper sea. There it hovered, not for seconds, but minutes. Sonar could no longer track it, but a nearby NATO vessel, the FS Pégase, a French frigate operating on the surface, reported a sudden disturbance on the water directly above the Kavala's coordinates. A circular upwelling, not a geyser, not a bubble plume, just a slow, concentric churn, like something immense had pressed upward, and then receded. By dawn, it was gone. No signal, no shape, no echo. The sea returned to normal, but the exercise was abruptly terminated. The Kavala was ordered to surface. Its crew was told to power down non-essential systems. The sub was then instructed to dock with a US support ship stationed farther west, where it remained for nearly a week. The reasons were never made public. What followed was a quiet dismantling of the entire operation. The Leviathan Protocol, which was scheduled to run through October, was suspended indefinitely. All mission records from August 23rd to August 26th were redacted from the official logs. The Cavala's commanding officer, a career officer named Reynolds with over 2 decades of submarine experience, was reassigned within the month. Within a year, he had resigned from service altogether. Some of the enlisted crew were scattered across the fleet. Others were discharged early, without explanation. One technician, interviewed years later under condition of anonymity, claimed his exit interview had less to do with naval readiness than with what he'd seen that night. He signed a non-disclosure agreement that extended beyond the usual national security stipulations. It wasn't just a new sub, he told the interviewer. And it wasn't an enemy. It was wrong. Like the sea decided to remind us who really owns it. The incident might have faded into obscurity, written off as a censor error or psychological misinterpretation, were it not for a document leaked the following year. Labeled Leviathan Protocol Internal Review Draft, not for circulation, the file appeared briefly on a secure academic server connected to an oceanography lab in Woods Hole. It was removed within 48 hours, but not before a handful of independent researchers archived it. The draft contains no names, no vessel identifiers, but it does include a passage that stands out. During Phase 4 operations, at approximately 0230 Z, Submerged Observation Unit registered a transient vertical displacement of unknown origin. Object mass undetermined, but pressure wake and thermal distortion consistent with entity exceeding 200 meters in length. No known biological or mechanical correlate. Recommend cessation of all acoustic mapping within 5 nautical mile radius of Site Echo Foxtrot 7. Protocol terminated. Analysis ongoing. Nowhere in the report is the word animal used, nor vessel, just entity. There is no mention of a follow-up. Some have tried to rationalize the incident. One theory suggests a natural upwelling. A rare volcanic plume or gas displacement event along the ridge may have caused the disturbance. But no volcanic activity was recorded, and the movement, by all accounts, was directional, intentional. Others point to sonar ghosting, a phenomenon where layers of water density distort signals, creating phantom contacts. But this doesn't explain the pressure changes, the magnetic spike, the disruption on the surface. There are even those who believe the object may have been a form of marine life. Perhaps an undiscovered species adapted to life at extreme depths. Giant squid have been filmed only in recent years. Could something larger, quieter, and more elusive still dwell in the abyss? A biologist from the Royal Naval Research Unit once suggested an unsettling possibility, that the creature, if that's what it was, may not dwell in the open ocean at all. It's not the depth that matters, she wrote in a private paper. It's the vertical behavior. Rising, watching, returning. That's not migration. That's surveillance. But even this theory fails to answer a deeper question. If such a being exists, why now? Why during a NATO exercise? And why was everything erased? Some believe the Leviathan Protocol was never truly a training mission, that it was a test, not of hardware or tactics, but of readiness. Readiness for what? That remains unclear. There are references in related documentation to Category 9 event horizons, a classification absent from standard naval terminology. These entries are sparse, often followed by redactions, but one passage survives in full. Should contact be made with submerged body exceeding operational silhouette tolerance, initiate silent return. Under no circumstance is sonar challenge authorized. Observe, record, withdraw. The language is precise. Observe, record, withdraw. It is not the language of confrontation. It is the language of submission, of retreat. Whatever rose beneath the Kavala was not meant to be engaged. One final fragment, buried in the metadata of a declassified bathymetric chart, bears mention. It is a coordinate, unremarkable at first glance, nestled within a trench north of the Azores. But in the notes, a handwritten scrawl, Echo Foxtrot 7, still active. Recommend reclassification, abnormal seafloor behavior. Second contact not ruled out. No signature, no timestamp, just a note, as if left by someone who saw too much. The Leviathan Protocol, like so many undersea events deemed non-operational, now exists only in rumor and fragment. But its silence is louder than any sonar ping. And in that silence, we are left to wonder. What exactly did NATO see? What moved through the depths that day in August? And why did it rise? The mid-Atlantic ridge continues to spread. The seafloor continues to shift. But sometimes, something else moves. Not tectonic, not volcanic. Something vertical. And when it does, it leaves no trace, just whispers. A terminated protocol, and the unsettling possibility that the ocean holds more than secrets. It may also hold sentinels, waiting, watching, and rising only when we get too close. But not all movements in the deep come with warning. Some come with purpose. The ocean holds its secrets well. Some lie scattered across the seafloor. Others drift silently through the deep. And a few are still moving, unseen and unrecorded. What we've explored today is only a fraction of what remains hidden beneath the surface. Lost missions, abandoned vessels, and signals without source. Each story ends with a question, and most never get an answer. But that's the nature of the deep. The closer we get, the more it pulls away. And sometimes, the silence says more than the data ever could. If you've enjoyed this journey through the uncharted and the unexplained, make sure to subscribe and dive into our other documentaries for more mysteries that defy logic and challenge what we think we know. Thanks for watching, and as always, until next time, stay safe out there, especially in the dark.